ready to go here. So, as I was saying, it's Tuesday night, and welcome everyone to the Keshe Plasma Reactor group. I'm Rick Crammond, and I've been doing this group for about 3 years now. And I guess we're ready to dive in. I'm not sure. As usual, I'm completely at odds with what to do, and we will just improvise as we go by having people contribute and just see what we come up with. So, just see here, make sure everything's tickety-boo. All right, so has anybody got anything to report for this week? Anything new to show? Perhaps a new...
Yeah, I got something to add, Rick. This is John.
Yeah.
I just got done watching the in the United States here the president's State of the Union speech.
I heard that was going to happen.
Not a big deal. One of the things I noticed, I kind of pay attention to some of the words underneath the words, and one of the things I noticed was he's coming out in the open now about releasing new technology. He hides it behind the veil of climate change, but I get the sense that there's going to be a welcoming of the new technologies in the United States. So I was very pleased to see that. And some of his other words, you could kind of tell were also hinting for changes to happen out here, something that's well needed, not only here, but throughout the world.
Right on. Good. Yes. Well, I think that there's something big coming up in terms of energy and so on. I think the major companies, corporations, and world governments are braced for this and sort of gearing up for it. And I mean, we see now the collapse so much of the price of oil has dropped down to almost $30 a barrel, and I wouldn't doubt it goes down to $10 a barrel. They might actually have to pay people to take oil because it might become such a liability in the near future. And much of the economy is based on that and so on. Of course, it's all going to collapse unless we have alternatives to immediately bring in from the wings. And I think the corporations and companies and world governments recognize that, and they do have things that can be brought in. So they're opening up to that now. They realize the gig is up on oil. Like, for example, Volkswagen has totally blown it. What can we say? They lied for 7 years straight, and on their emissions. And once it turns out that emissions are not just climate change, but actually changes people's DNA, changes people's attitudes, changes the emissions are killing people, put it bluntly. And recent research has shown that asthma is directly tied to diesel exhaust. They have found the carbon nanotubes lodged in kids' lungs. That's what is apparently one of the main causes of asthma. They haven't been able to determine that yet until just a couple of months ago. And now they can actually tie in those carbon nanotubes directly to a particular tailpipe, even to the point in their very near future of knowing what exact tailpipe, not just a certain fuel source or type of fuel or where that fuel came from, but where that exact nanoparticle originated from. And if that's true, then there'll be enormous health tiebacks into various industries and right down to lawsuits against individuals for polluting. And this is going to tear apart the whole industry. And once we find out all the manufacturers have been cheating, oh, that's going to be really bad, and especially the truck manufacturers, because they're one of the greatest sources of these nanoparticles. And so that's, the changes are there. It was just a news item yesterday that they're going to be, Volkswagen is going to be forced to buy back hundreds of thousands of vehicles from just in the US alone. And that's going to be a major, they have to buy back vehicles that are 7 years old. That's crazy. So they better come up with an alternative that's better than diesel, because that's not going to work for them. They, of course, they have electric cars in the back, in the sidelines, ready to go, and they'll come up with some new innovative way of keeping in business, I think. But it's interesting. We are seeing major changes happening in the world right now. There's all kinds of interesting things happening. Everything from people being more interested in spiritual type matters to, for example, I got an email that, or a Facebook notice that came in today from some friends in California that have a flotation tank business. And they've been doing this flotation tank business for 45 years, okay? But this year in particular, and in fact, just the last month or two, it has practically exploded with their business. And now they're sort of an overnight success after being at it for 45 years. That's for flotation tanks, if anybody's interested. It's quite an interesting thing. And maybe that's a way that, in a way, that might be something that's useful for people that are interested in space flight and interested in, if you're going to be in a spaceship, maybe it'll be in sort of a flotation tank, and we'll have to learn how to exist in that manner while we're traveling, perhaps. I don't know, just kind of putting that out there. Anyway, what else have we got to show and tell here, ladies and gentlemen?
I have some things, Rick.
Alrighty, Denny, do you want to put your video on, or how would you like to present today?
Well, I am going to present a lot of things. I'll start out with my
Go ahead.
little tower here, star formation tower.
Holy cow.
The thing that this does,
Can you
it
hold
keeps
the camera steady so we get a clear image there? Because it's kind of, oh, okay.
I'm coming back up.
Yeah.
So this right here is basically where the base plate goes. It can move in and out, but primarily it stays stationary. Why move 3 when you can move 1? Isn't it got a crank on it?
A crank on it? What?
So it moves this one down, up and down.
Uh-huh.
It goes down to the base plate, so you can find the sweet spot.
Yeah.
This is just the concept. It's right now, it's got fishing line on it, so it's bobbing around. What I'll do is I'll put a rack gear in here, so it comes straight down, and it comes straight down, straight without the movement. So when it gets into the sweet spot of your base reactors, your 3 base reactors, it's easier to move 1 than it is to move 3. So that's that concept. This is 1/2-inch pipe. I will go a heavier pipe. This little cap here, that's where you can put GANs.
That's a surprise. That's nice, yeah.
And each leg here is independent of the other leg, so you can have 3 types of GANs. This is a tripod, so that
similar to your wire structure you had.
Yes, I've got it made out of copper, also being made out of wood. The wood is going to be easier to, I'll probably move a dowel up and down pressure, where I don't have to use rack. Here's a little frame for a single power. It just sits flat on this, or on this one down here, where you can hang your batteries from it. This fills with GANs, but it's not independent like the 3 legs. It's got to have 1 type of GANs.
Is that glued together? Do you glue these?
No, I don't glue them because there's no pressure behind this.
Right.
There's no need to glue them.
Like
That way you could ship it.
in theory, you might glue them, and you could actually maybe create a vacuum inside if you wanted to as well, instead of GANs.
Yes, what I've done here is just made the shape, give people ideas that moving one rather than three is easier than sliding these out, but you can still slide these out if you want. Here's a 3-stacker unit system. Let me get back here. I'll put this up so my camera's steady. It's 3-stacker. 1 stack can be on this. 1 stack can be on that. 1 stack can be on that. And what you have is a very inexpensive system. What we have here, it has 12 T's and 4 caps, and the rest are the little 1/2-inch pipes.
Mm-hmm.
Hey, Danny, how about making it out of copper there? I know she had a lot of the copper fittings and such.
They're right here.
Making mine out of copper.
Yeah, they were, when I first bought my copper, this was my idea. So the gauge was smaller because the T's are strong. And but when I go to the tripod, I need a little stronger. I think 1/2-inch copper. And let me go on. I'm going to do a share screen here for a moment. And okay, I'm going to click on this one. So for the plastic, I'd run a rack up and down it, a rack gear, so that it, and they're fairly inexpensive. I can get 10 of these and a plastic system to put it in there. Really, once you get close to your sweet spot, you don't really need too much movement. You don't really need a big, long rack. However, there's so much flexibility in this. You can make a larger frame. Okay, I'm going to go to, let me see here. Well, you were talking about the copper. That's not it.
How do you attach those gears, Daniels? I'm wondering how you attach the gears.
Okay, let me go back to my, since you're going to ask that question. But first, instead of using solder on your copper, use just for copper. It's like a copper glue. You take a 60 grit sandpaper and you grit your joints. Let me see here if I can annotate. This is this wasn't what I was. This is not the screen I was hoping for, but so this is just for copper. You take and it has a 60 grit sandpaper that goes in. You sand your joints, and you don't blow the dust off. You keep that on. This particular stuff is non-toxic, and it puts your copper together. So what I'm looking for is to make this whole system easy. So when I instruct somebody who has never done it before, I can then do it. That's what I'm going to. One of my process of getting my Zoom channel is to put together some Zoom videos that starts from the very beginning, and that's why I'm going to go stop my share screen here, but for a moment, because I don't need to be on here. So let's see. Maybe I'll redo my camera. So does that help on the copper, John?
Yeah. How about if you didn't use any glue, just like you're not using any glue for your other fittings, and that way you don't get into
Copper is really sloppy. It's really hard to it's really hard to maintain now on this 1/2 inch. You may want to go heavier, say if you're going to this tripod system, like I'm showing here with the copper, the quad system is nice, but you're having to move your 3 bases. Here you don't. And so let me see, if you want me to take this apart, all I got on this one is a thread that goes, everything's backwards. When I'm looking at my camera, I can't find my crank. But all that is it cranks the thread, lowers it and raises it. Okay? But I would set it up with a rack. And of course, it's going to take a little bit of effort. The gear would have to be up here, and the rack would come out here, and you're going to have to make a special effort to come in between the fittings. Let me see, on this particular tripod, there's 6 T's and 6 elbows and 9 caps. These here are pretty much for decoration. The cap down here, but it does hold it together. It's not necessary to go to that expense, but plastic is pretty inexpensive when it comes to building a frame. And the idea of moving 1 instead of 3 is a easier concept than moving 3 of the best blade plates out. Now, what I have also is for wood is I use 2x2 furring strips. This was when I was working on doing the quad, but just give me a moment. I get my ears back on here and see if I can't get this into the screen. I'm going to readjust my camera. So when I find that furring strip, okay, I see my hand. There's the furring strip. So that's quite a bit bigger. And let's turn it around. You'll need 3 because it's a tripod. And I dial it together. There's no metal in it. Down here where the base plate is, that's a dowel that can slide in and out. Up here at the top, as soon as I find it on my camera, up here at the top there's a hole. And how I do that so that I can join those 3 tripods together up here, I just have the legs a little bit shorter, 1.5 inches shorter. The other, you have your main one, then you have one that's 1.5 inches shorter than that, then you have one that's 1.5 inches shorter than that. So they just stack one right on top of the other. And that way you can put make your triangle. I'll have this made tomorrow. I was hoping to have it done today so that you could see that wood has its advantage. No nano coating involved per se, but you can't fill it up. It's not hollow. It doesn't have a hollow leg. And the thing of it is, you don't have to use a string to run down the center. You can use a dowel that goes down the center, that controls the center
your center ring there.
Yeah, your center ring.
Your center coil. Now I'm trying to get clear on how that would work to move it up. Is that your gravitational coil, I guess, the inner coil, correct?
Well, this one here is just so that I can do this for demonstration purpose only. You would have a completely ganced coil with it perpendicular a perpendicular coil in here. And
basically is what you'd be doing.
yeah, and the whole idea is too is if you have a 3-stacker, you would put your 3-stacker in here, your double ones. You'd make your frame bigger. You'd make it out of whatever material you want. I'll try to get my pitch and awe right here, because look at, I don't have my, so that you would then raise and lower. You wouldn't have to push your base out. You make your frame big enough so that you know that you're going to get close to your sweet spot by just measurement and thought, and so it wouldn't take much to then know how big a up and down movement you have. So I'm going to do a little bit more of a share screen here again and see if I can find, yeah. This was the idea. Of course, let me see here. Anybody can draw on this if they want on this thing here. But you see, this is a tripod. That's the third leg. And this right here, this little gap here represents that this is, it can be bigger, or, you know, it can be bigger or smaller. Those gaps there. I mean, you can have a height of whatever you want. And this just demonstrates that this is the idea. It's when I was using string. You're going to crank the string.
Okay, in that case, Denny, would the string attach to that top reactor?
Goes right down through the middle top. You are correct. Let me get.
That would be the one that gets adjusted. Would be that top one then?
Yeah, that's the only one. This one right here.
Right.
The string here, just you crank it, and this right here. Let me get my my dimensions right here. This will go up and down.
Mm-hmm, mm-hmm.
These three stay stationary. However, this is wood, so I can have a dowel that can go in and out here as well. So it depends on how long I put this piece that goes across here. You know, like you can go any distance. So you can go as small as 68 inches, or you can go 2-3 feet. Depends on how tall you want this. What you can do then is you want to be more professional, and you get this going. This can be motorized. You can stand back and you can watch this unit, especially when you're dealing with plastic or copper, even with wood. You can put a rack in that as well, a rack gear.
I wonder how much that paraphernalia might interfere with the creation of the dome part of the fields in this system. You might have to have it all be the same kind of material.
Yeah, that's what this is all wood.
Mm-hmm.
Another one could be all plastic, you know.
I mean, you could have a wooden crank and a wooden spindle.
Yeah, all wood.
And hemp twine or something, which is wood.
Well, you can use a dowel. So that way this can move straight up and down. You get a string. That was my first idea, was the string. You might get...
you mean put a dowel in through the top fitting there even?
Yeah.
Attach a string onto that, or your gear, or one or the other.
Yeah, your gear, or you can make a rack gear, or one of the ways you make your own rack gear, or you can buy them. You can go on.
Well, this is a good idea, this idea of adjustability and fine tuning. I like that.
And so it's now, let's say you like the 3-stacker system. Then you just put your 3-stacker in. all of this would be, let me get myself back in gear here. All of this would be taller. All of this would be wider.
Would you have three separate gear mechanisms, or have one that?
No,
three.
Now with this particular idea, people can choose what they want. This is just breaking the mold, so to speak, so that the idea is out there. Because I think we got locked into the idea that we needed to move these back and forth.
Mm-hmm.
And we kept this up here stationary.
Right.
Well, with this, you don't have to keep it stationary. You keep these stationary. And you move this up and down.
Mm-hmm.
And if that doesn't work for you, you can make these longer.
Mm-hmm.
You know, you can readjust your system, find you're getting close to your sweet spot. You're understanding what your personal maggrav power supply units are doing. And if it's a stacker system you're using, then you're going to have to allow for the size. On this one here, the one I've got out of wood, the one I got out of wood, let me get here. As soon as I find it. See, there's an inch dowel that goes through there.
Mm-hmm. Right.
And it goes down through all three legs.
Yeah.
And each leg is 120 degrees apart.
Yeah. Here's an idea. What you can use that dowel as your adjustable pin.
What I will do, and what was the intent, is inside through that dowel, I'll drill the center out. The very center of the dowel will be hollow, and that's where I'll move my smaller dowel up and down that the center maggrav holds on, or the top power unit holds onto.
I was thinking the whole dowel might be able to move up and down, and just the legs would keep it from moving essentially, and you just adjust the dowel itself for your height. I'll probably want to make this tight enough that it stays. Otherwise, I'm going to run into a tipsy frame.
Yeah, it's too loose there. That's why the intent was to put a dowel big enough. And of course, this is 2x2 furring strip, which is 1 1/4 by 1 1/4. I mean 1 1/2 by 1 1/2. Mm-hmm. There's no limit to the size of wood you can do there. It can be 2 by 4. It could be 4 by 4. You know, your legs could be 4 by 4. Here's one of those little quad stacker units made out of a dowel and skewers, bamboo skewers. A simple, light system.
Danny, I think this is brilliant. I think you found your forte.
It's, I don't want to do all the work. I want somebody else to do all the work. I just wanted to prove that there's a concept that we've been overlooking.
Yeah.
Something that strikes me while I'm looking at this, Denny, is having the coils hanging on a string or a wire, or not fixed in a solid position. The field strengths are going to be pushing them around, and they're going to oscillate, and you'll never find your sweet spot.
Well, what I tried to relate earlier and probably didn't articulate it well enough. Well, let me see, where was I? Was this just for copper? Okay, what I'm going to do is go to this. See this, let me do my annotating now.
We don't see anything right now, but you're
Do
on
you-
your screen. We see your screen, your screen share for you.
Do you have that? Can you see me drawing an arrow toward this?
Yeah.
Do you see an arrow toward this gear?
Yes.
Yes, yes.
Okay, this is a rack gear.
Yeah.
This will be the piece that moves up and down.
Okay.
That'll be a sturdy, strong piece that guides through a groove, that doesn't allow that top of the star formation, or the top unit on the star formation, to wobble. It's stationary. That's why you'd want to go to a rack and gear. So you can see that these right here aren't too expensive to purchase.
Mm-hmm.
And
Yeah.
once you measure and you get your star formation set up, you may not have to go very far before you find the sweet spot. So this throw between here and here may only be 2 or 3 inches. It could be less. And what the whole system's for is now, it's not only just for flight, it's for how am I going to make materials? And if you're making materials from your star formation, then it's easier to regulate one. And if you want it motorized, where it just moves very easily. See, now you can see that I could crank this with a simple plastic crank I made, and everything in the plastic unit would be plastic.
Mm-hmm.
And everything in the copper unit would be copper. You might have to make your own copper rack, but you definitely can get copper gears if that's the direction you go, or if you even want to do it that way. And it doesn't matter sometimes what material you make it out of. You may want to make it out of a steel pipe. You may want to make it out of metal conduit. You may, electric metal conduit. This is just because we've had our mind frame on moving the bottom 3 in and out. I just wanted to shift the thought and then show how it can be done.
Yeah, I just wanted to bring it up because we got a lot of people that are just copying what they see, and with your drawing, it looks like your coils are just hanging off the end of your dowels. And I wanted to make sure that people understand those coils, the assemblies, the 3-stacker units, or even a single coil assemblies, they need to be fixed in a solid position. They can't just swing loose on a string.
Well, you may want to do it that way, and it may work that way, but because it's simplified. But what you're trying to do is get more refined and more refined. Remember, this is a crude system, and what I intend to do is start doing a presentation that's a little more refined as I make this.
What occurs to me as we speak about this, that it would be interesting to hang it by a string and see what the field forces are, see how it actually responds. Does it want to rotate and continue to rotate, or does it want to rotate in alignment with the Earth's magnetic field, or does it want to rotate in alignment with the other coils on the assembly? And so
if all 3 of them were hanging from a string, what would they do?
Right.
Would they
try to find their own positioning that would be optimum, for example, and maybe we shouldn't be locking them down too much and interfering with their sort of natural position? Or maybe they'll just do the funky chicken and we'll realize, boy, we better nail these things down because...
Well, you want to have the options.
Swirly.
You want to have the options. You want to have the option to be able to make it sturdy, and you want to have the option to test to see what the pendulum effect would be.
Mm-hmm. Yeah, and it's true when you mentioned pendulum effect, and we saw it earlier, and we can actually see it a little bit in your video screen there. If I was to show your video
Let
screen.
me get off of the share screen and let's go
Sure.
from there. I don't plan on taking too much time.
We can
but-
see the hanging coil up in the upper left-hand coil there, upper left-hand corner.
Yeah.
Of the video. And you see it's oscillating.
Well,
Back
I
and forth.
bump my frame every once in a while because
Yeah, well, this is the thing, though. It's virtually impossible to keep something like that that's suspended perfectly still. And
Yeah.
so it's always moving in the Earth's magnetic field and in the fields around it. So it may make that coil more dynamic and more alive to keep it, to allow it to have a pendulum swing. And the length of the pendulum arm, or in this case, the wire or string or whatever, will determine the period of the pendulum, how long it takes from one side to the other,
and you'll have the same effect down here.
It could be very critical, that pendulum interval, because somewhere in the neighborhood of 1 or 2 hertz, 1 or 2 cycles per second, or even up to half a cycle per second or something like that. That's actually a critical range, and it could be that in certain harmonics of that, or certain periods, might just tie in with some kind of plasma effects. Interesting.
Let me just give a little variety to this. Let's say you want your units a little closer in that way. That's one quick way of doing it. And you're down here with one that's dangling too. And so when this one up here is dangling, you got 3 more down here dangling and spinning. So if you find that this is not the effect that you want, then you can go to the stationary. Then everything is held tight. And the only thing that's moving is the vertical up and down of this until you find the vertical up and down of this until you find the sweet spot that you're looking for. That's with the rack and gear effect.
You've mentioned the word sweet spot a couple of times. I'd like to get a little more of your opinion of what that would be, and how does one find the sweet spot? What does that mean? Is it something you feel or sense, or is it a objective measurement of some sort?
Well, you start with an objective measurement. You know that each one of these base ones are equidistant if you choose. And you might suspect that this one right here makes a I forget the name of the solid that makes that pyramid-like shape here, where everything is equidistant.
Tetrahedral, I think, right?
Everything is equidistant from each other. And the sweet spot would be according to what I'm trying to get out of this. Am I trying to get a material out, or am I trying to get flight? And so that may be.
You're talking about more like an observation then of what's going on, you might say. If you saw it starting to shake like it wanted to take flight, that would be an indicator. Is that what you mean? Or
yeah, if it starts to.
So I'm trying to determine, is it something that's happening in the space, or is it, do you sense it inside of yourself? How do you tell where the sweet spot is? What is the sweet spot? Is it an internal thing or an external thing, or mixture of both?
I think you would start with just the structural tetrahedral effect. What's it? And you try to get to that particular point where everything's equilateral. And see what will happen there.
We do have a certain knowledge about that. Is right. It's like we know that is a basic shape of the universe, and in the center of that shape is certain special things going on that so-called free plasma effect is. Oh yes, that makes sense. Okay, carry on. Didn't mean to interrupt too much there.
No, I'm just saying that you can see my mess over there where I was working on the wooden thing and trying to get the dowels.
I can hardly see a thing with your hover coil there. It looks like a hover coil because you can't see the thread for it. It's just sitting there hovering.
Well, that is a
cool, actually, in a way.
That's a fish line.
Right. Okay.
Because I wanted everything to be plastic, except for this.
Yeah.
And so this half-inch pipe was chosen primarily for this experiment here before I decided, well, I better do this one too. This one makes it a little flimsy with the half-inch. I'd go even, if I wanted to, I'd go a 2-inch tube. This would be a 2-inch tube. This right here would be. And what I'm saying about when I'm making materials, I'm filling up this tube with something so that I can get the materials. I'm looking for materials eventually as well. So not only am I looking for flight, I'm looking for materials. I'm looking for a health unit. So what's so nice about this, I can have several of these placed around easy enough. You know, last Knowledge Seeker, we were talking about what would happen if this pin that was sitting inside these units, where the center of the wire was set up as a battery. And so then I asked Mr. Keshe, what would if I took the inlet wire that goes to the center gravitational coil and the outlet wire that goes from the magnetical outlet coil and hooked them together? And he said that would create a battery. Well, that's what I've been wanting to do, is make a toroidal battery. I didn't take that line and take it further and ask you more questions about that type of battery. But what I want is to eliminate wires going from here down to the base coils. I want to eliminate all those. Eventually, all this wire and stuff will be eliminated, but until that happens, I've got to, I'm using what I have.
So you're saying, like, normally I see there's what, 4 wires that come out of your.
Now this is not a complete one. This is just this right here is just a coil that I made. It's the large coil.
Okay, so when you talk about converting into a battery, could that one single large coil be converted into the battery configuration that you were speaking of, or would you do inner and outer?
Let me go do a little drawing here on the whiteboard.
Okay, thank you.
So I'm practicing this whiteboard so I can get better. Okay, so now we know we can make coils. Okay, and we know that what's hard about doing this thing here is you can't, I want to see if you can copy and paste. No, you can't copy and paste. And once you make a coil, a circle, it's very difficult to make another one that fits right over it with this software. These guys, well, maybe we can do it this way. That wasn't quite what I was wanting to do. Okay, so now we're looking at we've got our, and then let me do one more thing. This is a double coil, but let me get one more thing in there. And let's see if I'm still on circles. I am. Oh, 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 oh. So you know what I'm trying to do here is to make the gravitational center coil. All right. And this red represents the wire that goes through it. Okay. And we know that, okay, I wish I could, I don't have that drawing anymore of the demonstration where the coils are already drawn for me. But let's keep going just for the sake of wasting people's time. And maybe they can learn what I'm doing, how to use their annotation techniques. Okay, this is going to be, let's change that color to something weird. I guess I didn't change it. But anyhow, good enough for the way it is. So I don't know what that did. Oh, I know what I can do. Undo that, undo that, undo that. Whatever that line is over there. Okay, back to this. This is going to represent the outside coil of the maggrav system. Okay. Now let me see if I can do something here. This one, this right here represents the inner coil. That's a good color for that. That was supposed to be it. So undo that. This is the gravitational inner coil with a coil inside a coil and the center wire. And this right here represents the outside coil. As soon as I get my, so I'm trying to practice this stuff and get better at it as I go.
Absolutely, this is a good place to practice this kind of thing. So,
well, I went and got me a free Zoom so that I could practice on it.
right on, good.
And so this represents the outside one.
And what's the green?
Whatever that one wasn't supposed to be there.
Okay.
Let's just say that's a little bit of plasma field, but
that's the interaction between the fields.
Yeah, this is the distortion.
Maybe.
I don't know if I could erase that. It all erases at once. Well, even when I use the eraser, it erases the whole thing. And so I don't know why the software is like that. You'd think that it would be a little more flexible. So when we talk to Zoom, we can tell them to get this a little better. Let's say here, okay, so what I'm doing here is that off of here comes our exit wire. Off of here comes it comes from the center. Anyhow, we know where it comes from. It comes from right here of the center coil. And here's our pin that goes through. So this is our entrance. And some people call it the negative. Let me undo that just so I can be a little bit prettier if somebody watches this. That's the negative, and so right here, this is the wire that comes off, that's the exit. Let's go back to the color that so that we can be a little bit up. You got to learn how to write an X. And people call that the positive. That's where the load is going to be. So when I asked Mr. Keshe about this in the last meeting, knowledge seekers meeting, here's some green. Now we can use some green. When we look and hook these two together, what does that do? And he said it would create a battery. Remember, I was talking about this this pin right here, turning that into a battery. You know, you put batteries around this pin, and we thought of that in your plasma reactor group last week too. Remember?
Mm-hmm. Yeah.
And so, likewise, there's supposed to be a pin in here. I could have used a different color. Let's see what color we should use. Black is always good. So there's the pin in, yeah. We know there's a pin in there. Did you know you could do this, Rick?
Do which?
Get these circles to do this for you?
Yeah, I was going to say maybe you can use either the option or control while you draw the circle to get an even circle. I wonder if that's possible.
Well,
you could try that. Otherwise, you can, if you draw from the corner rather than some edge, it'll keep the circle the same as a circle.
Well, I've been lucky today. And so what you're trying to tell me, maybe you can instruct me here. But,
let me
I'm
just
gonna
try something. I'll erase it if it doesn't work.
No, you go right ahead.
I'll just make a little circle on this side here.
That's all right.
The option didn't work. Let me try a different one. Control.
Yeah, anybody should practice this. They can all come into this and annotate on here. Anybody who wants to.
Control doesn't work.
Well, as you struggle away, I'm going to keep. See, last week, I was wanting to put batteries on both of these.
It's not giving me my handles. Let me undo that before you get carried away. Just a minute.
I don't care. Just go ahead, keep playing. When you get to where you
undo undoes yours or mine?
No, yeah, your undo would do whatever, because you're the one who's working on yours, and it's good to find out what it does anyhow.
It just seems to undo mine. It doesn't affect yours.
Yeah. So let me see here, because if we're using split capacitor batteries, they're going to go that way. And then you put your coil on it. This is so that people can understand what I'm trying to say here. There's no sense. Might as well. It's going. Let's put a few more in there. These are split capacitor batteries. They go back, they lock back in there. They're very similar to Alex's beads.
Yeah.
And see, not only that, what we've got to learn is how to control this beast once we get the walls on it. You know? And so, did you give up?
Well, I couldn't draw an even circle the way I expected to there, so maybe there's some other way to do it, but let me try one other way here. Nope, that doesn't work.
So this is fun. It's not as much fun as building a frame and gansing your plasma units and getting it ready to fly, but it's coming up with ideas to see what you can do with what you already have. And so, let me see. I go back here to the color. I was doing something like this, maybe. I'm not sure. And so, well, yeah, those are green. So you make your little, might as well turn that into green. So there's these little capacitor batteries. And we all know that in the process of our learning that these two, the inner and the outside coil, are closer together.
Right.
And that this green thing here don't exist. If I knew how to undo that, I would.
What green thing?
This line right here, it don't exist in reality.
That's what you're talking about.
That's a mirage. And so, and we've learned that we can turn these perpendicular to one another. We get out of there. Let me see here. Undo. I'm going to practice one more thing before I quit. This wasn't the direction I was going to, but let's see if we can squash this. No, we can't. Well, anyhow, we know that these are perpendicular to one another. See if we can get it to look like they're perpendicular. Well, in that case, we'll draw them. Oops. For some reason, there was a malfunction. Isn't this fun?
Well, if you had a drawing pencil, then, or some sort of pad or pencil, one of those electronic pencil things, it'd be easier to draw. That's hard to draw with the mouse.
I'm using a mouse.
Hard to make words too with the mouse. Eh?
Yes. So maybe we'll be able to link different kind of software. Who is our friend that does that software? Showed us how
Robert Esteban has some beautiful stuff that he creates on SolidWorks and so on. And then they can be flipped around and do the 3D thing with them. But almost any 3D drawing CAD type program could be used in a similar manner to what you're doing here, but you end up with something that you can rotate and create into a 3D object rather than a 2D.
Now we learned that we can put them perpendicular, and on the perpendicular you can change the angle of the gravitational unit to give you different effects. And if I could do that on the triangle, I mean the tripod that I have here, that would be wonderful too. So anyhow, what I really wanted to show you was the tripod, and I'm going to stop screen share, and that you can. There's wooden gears. Oh, I'm not.
We have a couple of people with hands up. They might have some questions here. I better.
Well, let's hope not.
Let's hope.
Okay, so
let's see if they have a question or something to present. Are you almost?
I'm done.
Wanted to present? Okay, I see.
I'm done. I'm just.
Well, let's see if there's any questions or if they want to present something. So we've got Selma and Lee Gordon. One of you wants to go ahead there and say something. I'll lower your hands and see if you can speak. There's.
I got a presentation.
Salama here.
Hello, Selma.
Rick, Salama here.
Hi.
I would like to thank Danny for his learning point. I learned so much from him today.
Well, you're welcome. Welcome very much.
It's just running in my mind, you know, Rick. Nano coating. Then after that, you GANs. Can we do it all at the same time? Anybody knows?
I think
nano coat and do GANs on a coil at the same time. Is that what you're saying?
Yeah, no. The nano coating is ready on the coil. So when you do the GANs, can you do it at the same time? If you are confident enough.
Well, let's say you were nano coating with plasma, okay, and then you had GANs in a spray bottle, and you wanted to try to nano coat and GANs at the same time. So you would nano coat with your plasma units, where you have two of them. You have two plasma units together. I got to see what I'm doing, and so they're sitting, and you're nano coating in between those two plasma units. Then you can probably spray with GANs and nano coat and GANs at the same time. Do you think that would be a possibility that you could try?
Yeah, that's right.
Do you have a little bit of caustic mixed in it, perhaps, to help that process, or what do you think? Would that destroy the
No. When you're doing your GANs with your plates, and salt water, can you put in the nano coated coil and GANs it at the same time?
Oh, I see what you're saying.
You know, I knew you were saying that, but I was trying to come up with a possibility that would actually answer it for you. And you would have to get to the point where you have power units that are making, you're nano coating your wires with your power units.
Correct.
And so, but you go back to the basics, and you're wanting to nano coat and GANs at the same time in the same, well, it's a pretty, I don't know.
Yeah, I was thinking the coil will become more solid with the GANs at the same time.
Yeah, but the GANs doesn't usually attach to the nano coating. It's created by the nano coating, and you lose some nano coating usually when you create the GANs.
Because of the salt water?
Yeah.
Yeah, I would reckon so. I thought there's a way past that, you know?
Yeah, if you were to put your coils in salt water, it would eventually cause a problem there. It would.
I was thinking of a shortcut. Sorry about that.
Well, it's an idea, but I don't think it would work that way. You might have to put a reverse current in order for it to coat the coil and maybe create some GANs at the same time.
Correct. You are correct.
I've seen the regular copper. I don't know exactly what caused the condition. I've seen the regular copper and especially zinc become nano-coated when opposite a nano-coated copper plate. I don't know like I said, what caused the condition. I put 1.5 volts and sometimes a little bit of caustic.
I get the idea that the salt will spoil everything. That we, you know.
Yeah, it's kind of forcing things back the other way, you might say.
You know, I'm still working on a process. For the life of me, I can't pronounce your first name. What's your first name?
Selma, you mean?
Selma.
Isn't it Selma?
Selma, what I'm still working on, and I guess I could show it, is making GANs with ordinary water or distilled water with the salt and the caustic in separate containers inside the water. And if anybody wants to bear with me, it's just behind me. I can go get that and set it here on my table. Just a moment.
Rick,
Sure.
it seems that Danny is a very dedicated man.
Daddy's what?
Dedicated?
Dedicated? I think so, yeah. Yeah, he's a lifer.
I got to get myself stationary where I find myself, Rick.
Oh, we see.
So that's just a distilled water container, some coils, and some nano-coated coils. Some of them I've rubbed off here just recently playing with it. And this is a skewer that goes across to hold it. But I just put the skewer in recently. Wait a minute. I don't have my head on. Just a minute. Now I got my speakers on. Pardon me for all my interruptions.
I'm not sure if they're actually working, Danny. I think we're picking up off your computer rather than, or your camera maybe, rather than your microphone.
Well, now I got it back on my head.
Yeah, I'm not sure if we're picking up your actual microphone that's on your head, though. I think it might be selected on the
Computer, huh? Okay, what I'm going to do.
It's clear. We can hear you okay.
Okay, that's good enough then. For right now, I'll adjust it when I get it. Okay, I got to figure out what I'm doing here. So, usually I just put a twig across here. That was during the summer, but a little harder to. So I'm going to reach down in here and get it because this is just an experiment. So it's a little bit crazier than the last time. This is GANs coated salt. Okay, and that's what's going on in here, and it's just ordinary water. I noticed that when these two coils, one of them started to. Right now, I don't have enough water in here. Either my containers started leaking, or it's just the experiment caused the water to evaporate. But it produces something. What it is, I don't know. But the reason why I did this is because I wanted to find out if I had to put salt in it. And now I don't decant, I filter my salt. I'm going to show one other little tool since I've got the audience here. There. Just a moment.
Danny's quite the showman, eh?
Rick,
Hello? Yeah.
Rick, Salama here. I did the same experiment that he's doing now.
Yeah.
With salt.
Okay. Right.
And I got too much of amino acid.
Mm.
I don't know how, but
what kind of salt content are you using?
normal, where you get off the rack.
Normal.
Where you get off the rack.
10% or so?
Yeah, 10% salinity, correct.
Okay. I wouldn't go any more than that, really. I think it's best to keep
So
it
what I've got here is how I get rid of my salt out of my CO2 kit. So I took a bucket, a little container, and I cut the bottom out of it, and I cut the bottom out of the lid, and I cut the center out of the lid. I got a filter, and I'll show you what kind it is. And then I screw the lid back on. And then I have a container here, and I just pour my CO2 kit, salt water and all, right into that. And it drains through this filter. And when I'm done, I got a paste that's left inside there. I can take that paste and wash it again and wash it again. With more distilled water. And I'll show you what these filters are. Back when I was growing up as a kid, we had a milk separator. And these are milk filters for that separator. And you would filter your milk, keep the dirt out of it and all that. But so this is an easy way to separate your GANs from your salt water, is to use a little simple homemade device or a filter to quickly do that. You just, again, cut out the center of the lid and cut out a bottom, and you can use this to empty it out. It doesn't go through there very fast. Sometimes you have to stir it to get it to go through. So,
have you ever let your salt water sit for a couple of days after doing that? The stuff that comes through filter, to see if there's any.
Yeah, I have, but I've been negligent on that side of the operation, and
what I would suggest is with that type of procedure is you'll get the bigger chunks of materials and compounds and so on. But the actual nanomaterials, the actual GANs, not really particle, but the GANs entity,
I see
is so tiny that it would pass right through the filter and would not be seen, perhaps.
Yeah, you have to let it sit to see what went through it. Yes, I do that.
Right.
It's negligible. Yeah,
I wonder if maybe the best nanomaterials might go through the filter and be in the salt water, and it might be a way of actually obtaining a finer grade of the nanomaterials, the ones we can't really see so much, or GANs, rather.
You know how Renan does it. He doesn't even worry about the salt. He just dilutes it. He doesn't go down into the bottom of the GANs. He takes it from the water, dilutes that water, and he finds he gets a value from it.
Yeah, the GANs water actually would have, I think, the finer nanomaterials in the same way that homeopathics are used. They do this, shaking process or whatever with the homeo. So they figure that by the end of that process, there's not supposed to be any actual particles left of the material that you start with because it's been diluted so many times. But now, just in recent tests, they have actually detected nanoparticles in the homeopathic remedies. So it's not true that there's nothing left and only the signature of it or whatever. It's because they could never measure the nanoparticles before. It's only been recently they've been able to find nanoparticles, what they call nanoparticles.
Well, I was a little concerned too whether the amino acids would go right on through the filter. But if they did, that would be pretty nice, because then you could collect them afterwards.
And then what if they get mixed up with the GANs as well? Then that would be a...
So people were after a paste, and they were heating and drying it. But you just filter it and you got your paste right there, and don't heat and dry. It's just what's left in that bucket is a paste.
Yeah, that's the way they usually do it in a lab. They'll put a vacuum chamber underneath the filter and just suck out all the moisture, essentially. And you're left with whatever's in your filter paper. Those are quite the filter papers. The milk ones, that's probably a high quality.
Well, I was going to use them for the health pads too.
Oh yeah.
Especially when I'm done filtering it, then I use it for the. So, did somebody have a question that raised their hand?
Salma, you had a couple things there. Maybe you're done. I'm not sure. And,
Yeah.
Lee Gordon Coates said something.
Like Rick, the amino acid that you get is very difficult to collect. You got to collect it, like scoop it up.
Right, it's on the surface. Well,
After that, then you can filter, or you can make it more like a paste. Then you have to redo again, like rinsing it, the salt or whatever. It's very difficult to collect.
I wonder if it would be possible to pour it off onto a filter paper similar to Denny's. Just pour off the top.
Yeah, I've been using the coffee filter, but not so good. Huh?
I see.
I'm also wondering. There's a system they use to get oil off the oceans. They could come up with a little material that would.
Mini one of those, yeah, like a cotton sort of conveyor belt thing that it squeezes out on one end and absorbs it on the other. Just let it run in your solution, and it's sort of got a little mini ringer washer machine.
I have a question for Robert Avers. How do you say your last name, Robert? He's the software man.
Yeah, hi, Robert. Well, Lee Gordon Coates had his hand up. Maybe we should.
All right. Yeah, let's see what Lee has.
I just wanted to show off my unit, so
Sure,
I didn't have a questions.
All righty.
That'd be great. And,
yeah, I've taken enough time of everybody's time.
Well, you get back to your question for Robert after that, because I'd like to see what Robert's up to as well. But let's try to get one at a time here. Let's see what Lee Gordon has.
I gotta see how to get out of here.
Yeah, I think you have to turn my video on.
Oh, okay. That could be. There we go. Sorry about that.
Okay.
Okay. We can see your video. Yeah.
Very nice.
Okay. So
Interesting.
moving a bit closer here. I got my basically that's where I'm going to mount my coils in this unit here. This is just some PEX pipe to make a circle. So I'll mount the gravitational coil off the red pipe, and then I'll mount the magnetic coil off the blue pipes.
What do you mean off the pipes? You
So
wrap the coil around them or attach it to the
Well,
pipe?
I got to make these. So this, like the magnetic one right now, is just sitting on a piece of plywood in between the blue pipes. I got to make up some brackets or some more pieces of plywood, or I might make it out of plastic. That's
I
tomorrow's
was
job.
just looking at PEX pipe a couple of days ago and thinking, how could this be used? Now, you're not using the pipe itself as part of the actual field effects, or are you?
Well, these pipes have been nano coated in the GAN in caustic, and the rods here were nano coated in the caustic. But I'm thinking these plates, I don't want to I don't think these support brackets should be nano coated because it might short circuit out the coils or something. I'm not clear on that. But
plywood, right? Thin plywood.
Right now it is. I might make it out of, I was going to make it out of plastic, but that was just my first template I made out of plywood to see how it would work.
You know, it looks like your coils have an awful lot of GANs on them, or are they encapsulated? What is that?
Well, that's, you know, I just put them in the GANs bucket, and that's what it ended up. There's a bunch of this powder falling off right now. So that's, I got 4 different Ganses on the other coils, so some of them are thicker and thinner than others. But anyway, these units, they can slide in and out on the bottom board, and they'll also be able to rotate for adjustment. And then on the upper coils, now they're mounted. Right now that's mounted way too high. It's got to get dropped down a foot or so once it gets all adjusted. But
Denny has the solution for that, I guess.
So, but to adjust it up and down is just a matter of changing the nuts on the outside rods that are supporting.
Those rods, are they brass? Are they brass rods or what?
No, they're just steel all thread.
And were you successful in nano coating? They looked like a different color or something.
Well, these are nano coated, and they just turned a little black, almost rusty.
Yeah.
Okay. I don't know how much. I've never nano coated steel before, so
they do have these new sockets and ratchet sets that you see at places like Canadian Tire and so on. And black coating. There's the new black oxide, they call it. It's on steel. And I got a set a couple of years ago when they first came out. Thought, oh, this is great because I'm kind of allergic to the chromium and nickel plating and so on that's usually on these tools. So I thought, oh, great, it's black. It's unfortunately, it came off in my hands. I'm going to mute you there, Denny. It came off in my hands and actually irritated my skin and so on. So I decided that black oxide wasn't for me. But it is a method that they use, and we do know that there are types of iron oxides that are black. So that would be one type of coating, and of course rust or red oxide is another kind of coating for steel. And then they have diamond-like coating, which is not even steel, but a graphene coating that's put on as a protective sort of cover. That might also work in terms of not attracting the plasma to it to short out the system or short out the fields in effect.
Yeah. So anyway, this top unit it could play with. But
so those tubes, you're not putting anything in those red and those blue tubes, or is that correct?
I wasn't planning on it.
So you could drill a hole right in the middle of the red tube and hold up and suspend your coils in that fashion, kind of like Ollie did.
Well, yeah, but I wanted it more solid. Like these things are solid, okay? I don't want them flopping around. So
I think
I don't want to
drilling a hole in your red coil, the top of the red coil, and suspend the unit from that, but you don't want it to just.
Well, the other thing is I'm using 16 gauge wire here, and it's really flexible, and this nut doesn't hold its shape very well. Mm-hmm. So I need solid support for it. Mm-hmm. Okay. I'll have to tie wrap it so I'm thinking of running the piece vertical up and down here with a hole cut in to support that one in the center, and then tie it to the red tube, and then the other one will probably be similar to what I got here. I was going to put my capacitors on this plate here, but I'm thinking it sounds like maybe that's in the way of the fields. Maybe I need to put the capacitors down the bottom instead.
Well, it's certainly an excellent opportunity to do the design that Denny was just talking about, and making a plasma battery or maybe capacitor inside the coils, inside the PEX tube coils.
Mine aren't that small.
Asking for it, really, when you look at it compared to what Denny's just brought up again here. It would be a perfect way to create a plasma battery, and you've already got these opposing fields which have got to work together good somehow. I don't know. It seems like a
This is a good system. This is a good system because it's easier to keep everything sturdy.
Yeah, and you could use PEX pipe here instead of this, or sorry, PCV pipe here instead of this PEX I'm using. It's the PEX doesn't want to bend this tight, and it's that's why I have to have it on the steel rods here to keep it in its bent shape a bit too. Whereas PVC, you can heat it up and bend it, and it'll hold its shape.
Right.
So,
True.
So
there's work at that.
like to get this shape, I heated that and bent it around a wooden form, and but it still wants to spring back. It doesn't want to stay where where I want it. So you'll see if you look at my rods, they're bowed out just a little bit, quarter inch or so, just from the force of the pipe pushing them out. But as a unit, that's nice and solid there, and it's not going anywhere. So so I think it'll work good. We'll give it a try.
Right on.
Can you show your top units again? Here. Yeah, what you're doing is you're using a single plasma generator in each one. You got 2 of them, rather than using a 3-stacker, right?
No, this would be a 3-stacker inside here, and a 3-stacker in there.
And 3 stackers at the bottom, right?
And 3 stackers at the bottom, yep.
There you go. That's real nice. Of course, now I'd have to hang it from my newly developed idea frame, but still,
yeah.
I want to be able to have those sturdy too. I want to have a unit that's completely sturdy as well. Yeah,
it's sort of hitting the ceiling here, but my frame right now is kind of wobbly. I'm going to have to probably put some wire braces in here on the diagonals or something to stiffen up the frame top to bottom, but because right now the top wobble back and forth. But that's still in the works.
So I'm gonna ask a question to see if I'm understanding your thoughts there. You have the red and the blue flex pipe in order to isolate each the magnetical unit so doesn't touch the gravitational grounding, so that you can keep them on separate supports.
That was sort of the understanding I got from the Knowledge Seekers workshop there a couple of weeks ago, when he was talking about putting plastic loops on them, was to keep the magnetical and the gravitational separate. So yeah, that's my intent, is to. So this plywood isn't any of the plywood between isn't nano coated, so that means these are isolated, plasmatically. So
thank you very much. For me, I like what you're doing.
Well, we'll see if my hand disappears next week.
Where a hole opens up in the roof of suddenly the light disappears and you can see the stars, you're there.
That's right.
Salama here.
Yep.
Why can't they do the rod inside the PVC? Where your circuit will become, it won't be shorted at any one time because you can control. And if you were to use wire to stabilize the coil, the perpendicular coil, it becomes like a loop. You know the loop?
Becomes part of the circuit.
It's a loop. It's going to become a loop that you can the direction of the energy or of the electricity. You understand?
I don't quite understand. No, but
You mean it'll interfere with the plasma or create a separate loop for the plasma if it's attached to the?
Because if your rod, you nano coat it, it will benefit the whole plasma field. But if you cover it with PVC, you've got no chance of short circuit, like what Kenny does.
yeah, except the other guys, the PVC is their magnetics and gravitationals are tied together through the PVC, whereas mine I got
No.
a separate
Yeah, that's why I said
gravitational, separate magnetic.
when you see Ali does it, he used two coils to stabilize your
Okay.
perpendicular coil. He used two wires, sorry, through the PVC.
Yeah, I think if it's the one I'm thinking about, his wasn't too solid. It was pretty wobbly, but I'm not sure.
Yeah, I saw it as rather solid, and it was approved by
Okay.
Mr. Keshe.
Okay, maybe I haven't seen his latest version.
Yeah, the combination of it is that the rod can be nano coated.
Yep.
Yeah, and also it's good for the health purposes if you want to use it, where your customer or your friend doesn't know where to touch.
Okay, like
For health.
this rod here is nano coated right now.
Yeah, so
But
if your friend want to use it as a for health, for cure,
yep.
he won't know where to touch. But if you cover it with PVC, it's very safe. You is the safety point of it.
So it's possible that you could create, in effect, a plasma battery from each of those rods by using the rod itself as the core, and then putting a plastic tube around it with maybe GANs or wrapped up aluminum. It could be, some sort of capacitor or battery in each of those posts. It's
Yes,
possible.
correct, Rick. I was thinking in that direction and the safety effect of it.
Where I don't understand, I don't see any safety problem here. What are you thinking would be a safety concern?
No, if your friend want to use it for health purposes,
Mm-hmm.
yeah, if it's already covered and all the safety aspect is already thought of, so it is better. And the nano coating of your rod is wonderful.
Yeah,
It can be used to amplify, and it can be used as a loop service, loop to your coil. At any one point, you can use it as a loop.
Yep. I mean, if like my house generators I've been building, I've been putting them inside plastic. Actually,
Yeah,
just some plastic from a bucket just to make them safe, so no kids can get their hands in there. Yeah, the wires and stuff. But
we going in the same direction then, Lee.
yeah, so
we're going in the same direction then.
But to cover it in plastic, how does that affect the field? I'm not sure on that yet. So
you remember Mr. Keshe did it? How he did it?
well, the MagGrav units from the factory, they're all encased in plastic. So
he have all the rod covering the gravitational, and he have different cords, different rod to cover the magnetic coil. You remember that?
I don't remember that one. No.
Yeah, he showed us how to do it.
There's somebody in the live stream that's asking, what is it for? So perhaps we should get back to some basics and just explain, because it's not always obvious what this kind of thing is for. And when it comes right down to it, when I think about it, I'm not quite sure either, because for you have a vision of what you're creating and what you hope to get out of it. And you mentioned the hand might go invisible and so on. So those of us who know have an indication where you're going with it. But maybe you'd like to explain to those novices that haven't followed the last 300 workshops at 4 hours each and know what's
Thanks.
going on.
Yeah, thanks, Rick, thanks.
Yeah, so if you go back about three of the knowledge seeker workshops, Mr. Keshe was explaining how we could build the Starship or get started with the Starship research by getting a plasmatic field, a large plasmatic field actually. So the idea was to put the plasmatic reactors. This would be one reactor inside that unit, and we'd put 3 on the base. So I got 3 on the base here, and then 1 above, and that's your Starship formation to get in the fields from all 3 of these generators combined to give you a bigger field. You sort of get a free plasma, let's say, in the middle when you get these combined, and then it grows out. And the one guy showing it last week had this glow right around his house. So, and then Mr. Keshe said add a 5th one up on top. So now we have the double one up here. Normally for the Starship formation, you just have this 1 on top, but now it seems like we're going with 2 on top. So I'm going to try it with 2 on top and see what that does. So and
this will be eventually plugged into household current, basically, to power your coils, or how is that going to be?
Well, I'm going to. I haven't made them yet, but I'm going to make the plasmatic batteries.
Okay.
I got some of the parts made, but I haven't made the batteries yet. So.
Okay, so it'll be isolated from the household grid circuit, you might say that.
That's the plan. Although I may
electrically, but we don't know about how the plasma, what it might do.
Yeah.
Yeah, interesting.
But in the
Lee, can I ask you a question?
Yes.
The battery that you will be using is the split capacitor?
No, Mr. Keshe has been showing us how to make the batteries, and separately the batteries are where you got the nano-coated copper in the center, then the GaNs, and then the nano-coated aluminum around it, and then wrap the coils around that. You actually got a split coil. One coil feeds back into the battery, and the second coil is the output on the battery. And I was going to try it with the twist in the center as well, as a more powerful battery, like he was talking about last Thursday. So.
Okay, just to clarify, the battery is not activated at any one point. It doesn't give any voltage.
You make these batteries. I think they're about 0.2 millivolts out of each battery, or if you measure it with a voltmeter.
Yeah,
mine don't do
At least
Alex,
the other ones I've made, that's about what the voltage I got out of them. So.
Alex bit when you measure, it's already 1 to 1.3 volts. Yeah, so I was thinking which one is better.
Well, make them both ways in the environment.
Question, I understand.
I was actually doing the
same one that gets moving works.
I decided that Alex's bead was the way I was going to go, and then just spray them with caustic, because I have a bunch of extras and I get way more voltage out of it. But I don't know if that's what we're looking for, actually, because my batteries, before I put the double coils on and connect one of them back to the negative, or what would be the positive from the negative, I'm sorry, I get in the very low millivolts.
Yeah.
But that's what it's to do. And so I'm thinking that that's just, it's moving the plasma rather than, we don't want necessarily a voltage. We want the plasma.
Right, we don't want voltage, we want plasma, and of course we can't measure the plasma. We don't know that.
Yeah.
I understand completely, you know. With Alex, it's like matter and plasma, but we're going through plasma.
Mhm.
And another thought in my mind, I don't know if you agree or not. The plasma voltage is not the voltage we measure. The plasma voltage is much more. Anybody agree with that?
Yes, I agree with that.
Yeah,
I
I'm
can
not sure
feel
if you can measure the plasma in voltage that way, but potential or some sort of what would you call it? Maybe a different word is required for measuring plasma. I don't know if a big plasma has more voltage than a small plasma. I'm not sure if it works that way.
you can feel it if you put your hands next to two batteries and hold them over, kind of close your eyes. You can feel a difference between the two of them. It's kind of like a breeze at first, but it turns into a tingle.
Mhm.
It's like what we don't know now, you know. It's like the plasma voltage that our measurement we take, right? This might be 50 times or even 100 times more powerful than what we can measure.
Could very well
Exactly.
be.
Yeah, it could be
What
very
we,
small, but
what we
moving that.
measure that doesn't show the true potential.
That's the
Right.
way I'm now.
I think that the true potential will be sort of unveiled in layers. Like it could be that a relatively simple apparatus like this might be able to put out, enormous energies under the right conditions when everything's tuned exactly and that kind of thing. And maybe we wouldn't even see most of the effects from that. So but on the other hand, there might be some interesting effects that do take place and definitely will at the higher energy levels if you're able to find the correct combinations to get into those higher energy levels when we're ready for it, because we have to get the basics sort of under our belt first. We have to have an understanding of what these feel like, creating this tetrahedron, pyramid type structure to start with, that indicates a certain understanding about the stability of this structure, and then you're adding this other unit on the top and so on. So you would kind of expect a certain thing to happen out of that. And then if you increase the Danzas and increase the fields and so on in different
You
ways, and it should have different levels that manifest. Go ahead, sorry.
you understand my understanding? When you do the energy, when you use the McGrath and all that, you know, our intention is, or our what we want is that we don't use the outside grid, so we achieve zero. Correct? Wherever
Well, if
we
that's your intention, yes.
yeah, so whatever we use inside the house is free.
Well,
So
Yeah, yeah, we're independent of the grid. We want to be in.
I think that's a good goal to have.
so
Yes.
so if we don't use this McGrath system, the grid have the signal to pump in more surge of current, you know, so we have to pay more, right? If we don't have a McGrath system.
Well, that's
Right, we don't have the flexibility with this MagRev
Yeah.
system.
But if
We're more independent.
you see my direction, if the grid doesn't have the signal, that means the plasma that flows in our wiring already covered what is needed. That's why we get zero. It's more powerful, or it's more than what we get from the grid. From
well,
the
we'll
sorry.
see. Yeah, there are people that are having good results, and if anyone does have any good results, whether it be for the power units or for health pens or different I'm looking for testimonials, actually. Mr. Keshe would like to get together all the testimonials that people can have of the success stories of the products and concepts that we've been working on. And there's a lot of success stories. And so we want to try to get them all together in one place. So,
Yeah. Dave,
Rick, you don't have any worries there, Rick. It's just a matter of time. All the testimonial will come in. I'm quite
oh, yeah,
confident of
we're
that.
getting lots of them. It's a matter of getting them all congregated and collected in one place. So that's what we're doing this week, actually.
So
Yeah.
when the time comes or the duration period is contained, everybody will get the same thing. Zero. All completely zero.
Good, very well.
yeah, I saved 52% over last month's bill already.
Yeah. Yeah, Robert, I reckon you managed to, huh?
Yeah. And that doesn't take into account the fact that we also like 33 degrees Fahrenheit colder this month than last month.
I can barely hear you there, Robert. Microphone. Well, I think all the microphones came over. There we go.
Sorry, that wasn't me. But yeah, and we stopped burning the wood stove because it was cheaper just to run the regular heater, and it cost us for firewood too as well. So we might as well just burn the
Great.
cheapest.
Well, keep us posted on the results of that, how it works out here in the weeks and months and so on. And I
Yeah,
think
it's on all of the results.
Just realized I don't have my co-host here, so I'll make Vince the co-host for now. Okay. There's a couple of questions in the chat here. Vincent Leong says, does anyone know how to make aluminum nano coating? This is a common question that's come up a fair amount lately. Someone commented that they tried to make aluminum nano coating and got a white substance on the aluminum. And I would suggest that probably is the aluminum nano coating. He was expecting to get a black nano coating. I don't think that's the case. Any comments on that? That would be using a copper.
That's my results as well.
Right.
Sorry. Yeah, that's my results as well, a white nano coating on aluminum.
Yeah.
Whether by heat, which you have to be really careful with, or caustic, either way.
Right. Yeah, aluminum, when you polish it, it immediately oxidizes, actually. And it's very hard to keep it not oxidized, but it's a very light oxidized coating, so it makes it look like it's shiny most of the time. But then when we use caustic, it puts a pretty thick aluminum oxide. You can see that right off the bat. I think Vince has quite a bit of experience with that a couple of years ago, making aluminum reactors and so on, round spheres, and putting caustic in and so on. Aluminum does dissolve in caustic, and especially like mentioned here in the chat, it needs to be thick so it doesn't dissolve. If you have an aluminum foil in caustic, it doesn't last very long, causes the caustic to boil up and give off lots of hydrogen. In fact, it's a very good way to collect hydrogen is to just put aluminum foil in caustic. It's 99% plus hydrogen that's given off. Okay, what else here? Yeah, that's right. The caustic and fire method are probably not the best way to go for aluminum. I think just a bit of caustic vapor would be enough to put a pretty good thin but nice coating on aluminum. Alrighty. Of course, with the aluminum foil in our capacitors and so on, there's a tiny bit of caustic is sometimes added as a secret sauce ingredient, and that'd be enough to cause the aluminum to have a bit of nano coating on it. Okay, what else do we have to show and tell here? Anybody like to present something? Hey Armin, your microphone's open. You must want to speak now.
Sorry, guys.
No, don't be sorry. Come on, speak right up. I saw your recent video. I haven't had a chance to play it back a couple of times. And you're showing the spiral wire connectors, this new concept that several people have taken up already. Is that working out good, Armin? Trying to bait him to talk.
How about like just a plain old copper crimp? I've seen copper crimps in the store where you can just crimp the wires together. And if that was nano-coated, it would be nano-coated to nano-coated. Or even the capillary tubes, if
then you
you
have
off
to
a piece
crimp.
of capillary tube and nano-coated it and use that for a connection piece. Will that work just as well?
People have talked about the capillary tube method already, and that's an idea.
Tubes are not flexible.
That's right. I was just going to mention they're not flexible, and also the crimp method would be tricky because if you crimp, then you're going to break through the nano coating, and that's kind of a no-no in terms of metal-on-metal connection rather than a nano coating connection.
Guys, you do all your connection, then you nano coat.
There is a problem with the spring wires which Armand shows. If you break it, you open it up, you lose a lot of your fields. The spring has to be continuous.
Like a closed spring, you mean, Mr. Keshe?
Yeah, it's got to be closed spring, yeah.
Okay.
The way you pull it to separate it or bend it, it cannot be, you lose everything. It's like an open-end wire, so you can't pull it and then turn it. It has to be done as a continuous loop. And the second thing, which now is on the discussion table in the factory, is the regulators are asking for, especially at the point of the wire from, let's say, live wire, from the plug or from the main, has to be screwed into or tightened by a screw method. No other method is acceptable, or they are at the moment accepting us because it's new technology, but they have asked us to look for a new way of tightening with the screw. So the connection.
You're talking about securing the hot wire that goes into the unit. Is that what you mean?
And the one which comes out of the unit to the load.
Mm-hmm.
They want us to accept it. They understand it's a new technology. It's been accepted. We have the licenses and everything. What they have asked us to develop a new method of securing with the screw to be to what do you call it, to secure it. So when we look at it, we are working on it. We developed a new, what they call them, tool for it, as you call it. And what you got to do is that on the live wire end, which do the twist on wire nano coated, and then you secure the go through a plastic connection, and you tighten it with a plastic screw, so you don't damage things. So this is what we develop. We do going production test. But the springs which Arman uses is good for, as he said, the pipes are not flexible. This is flexible, but you can't pull it apart to take it because the opening of the spring loses a lot of fields, especially if you burn to 90 degrees in an angle. I've seen a couple of Arman's units, they open up and they turn. We got to find a solution for this. It cannot be done. There is a way to do is just to twist the springs inside each other and make like 3 ways. But the field loss is huge. This is what, at the moment, we're looking at the factory and the production instrument tools.
No,
The,
we were
the,
whether it would be a loss of fields through that transition and so on. And now, would the fields be traveling on?
There's no losses.
Sorry, we can't hear you, Mr. Keshe.
Why?
Sorry, your signal is breaking up there. No, you're going to have to repeat that. We can't hear that, Mr. Keshe.
Not, you cannot open.
You cannot open.
Continuous spring. The way Arman on not pull the spring.
Don't pull the spring.
No.
I'm only hearing every second word or something there.
Hello?
Hi, Arman.
Yes. We can't hear him.
Yeah, you couldn't get the key words there. Can you try again, Mr. Keshe, or in another location maybe?
I think he means that the L shape is losing a lot of field.
Where you connect onto the main wire with your capacitor wire.
Yeah, capacitor. You can connect maybe series, but you know, the way the L shape is saying that you're losing the field.
Right.
Probably the transition has to be smoother.
Can you increase your microphone a bit there, Robert? You can barely hear.
Sorry, how about now?
It's a little better, thank you.
Yeah, I'm thinking maybe because it's an abrupt transition, 90-degree bend, it has to be a smoother transition.
Mm-hmm. So, how could that be accomplished? Use a coil and do that. Keshe was mentioning sort of an inside out coil arrangement. Have some microphone noise, Robert. There. Okay. Or maybe it was Arm. Mr. Keshe, are you still there, or your microphone is now off? I'm not sure. Not good, I think, is the answer. Can't hear you right now.
Hello.
I heard hello. Yeah, we're still trying to get Mr. Keshe in here clearly. Having some trouble with that. Okay, well, Is there any other comments about that? So I see you have your microphone open. Do you want to say something? Okay. Well, let's carry on. We're having trouble hearing Mr. Keshe here, so I think he's actually dropped out.
Hi, guys.
Hello.
Hi, this is Narek from Los Angeles. How are you?
Good. How are you?
Good, good. Yeah, I just wanted to, I had an idea. I mean, why can't they use glue instead of, because Mr. Keshe had to use screws. I'm guessing, I mean, why can't they use some sort of glue or adhesive for instead of the screws?
Because it's regulations.
Ah,
You
well, that
have
makes
to
sense.
secure it in some manner that is probably using screws, whether they're plastic or metal, they don't care as long as it's clamped down in some secure manner. They may not consider glue as a secure manner, I think. That is a way to go. Many things are glued nowadays with some good industrial glues.
Yeah, because we do have some really good glues that we can use.
But after the authorities say use screws, then you can come back with glue. It's probably not a good idea. Unless
Yeah.
you want to delay another 6 months.
Yeah, seriously.
Okay. Does anyone else have something to present at this point? Or something to discuss? I was wondering if Robert had any new drawings he'd like to show.
I had big plans for today. After watching the 94th this morning, I wanted to make some of the items that Mr. Keshe was presenting in the beginning of the 94th, but unfortunately didn't have any time to work on it, which is always the case. A lot of things to do, not enough time.
Yes, tell me about it.
But I'm
Is that
working.
something that you'd be able to present something for the Knowledge Seekers workshop tomorrow, perhaps?
I'll try, but no promises.
Okay. Don't want to pressure you or anything, but it'd be nice to see some sort of colorful assembly of some sort. It's always good for us to see that sort of thing.
Yeah, and I also watched some of Nassim Haramein's latest videos. Just continuing on the discussion last week, and I didn't see anything interesting that he had done. Actually, my opinion of him kind of got lower than it was before watching his latest stuff, and it seems like he's either not.
Hello, Mr. Keshe.
Nasami.
What was that?
What Robert just
You're breaking up really bad, Mr. Keshe.
Yeah, I wish we could hear what you said there. I think when you mentioned Nazreem or whatever his name is there,
I
got
think
Mr. Keshe going.
I touched the nerve, I think.
We touched the nerve there.
No. We can hear.
It's breaking up pretty badly, Mr. Keshe. We hear every odd word.
No, we had about.
We heard we had about, and that's it. We don't hear you, Mr. Keshe. Hi, Brett.
Oh, I didn't know I was unmuted. Sorry. I remember Keshe talking about Nassim Harriman a long time ago. About he was supposed to go to do some conference, and he came and took the book and did some other stuff. But I'll let Keshe talk about it, not me.
Yeah, I remember something like that.
Rick,
Uh-huh.
like there's a lot of attacks on Keshe technology. Yeah.
A lot of attacks, you say?
Yeah, they say that it causes people to be unwell and all that.
I haven't heard any reports of anyone feeling that way, but
There's a lot of it going around in Facebook and all that.
I
Uh,
don't follow those negative reports. Whenever I see a negative report like that, I just call them a troll and ban them.
Yeah, it's like Nassim. It's
so
like what Robert mentioned just now.
There's so many positive reports coming in that it's not worth listening to someone. They suspect that someone out there somewhere must feel bad from this.
Small attack.
Total bullshit. I won't put up with that, and I won't put up with people that have that attitude, because I have not seen one single bad report yet in the Facebook with anyone who's actually done the experiments, other than the HHO guy.
Yes, correct.
And badmouthed it because it's rotated now for 2 days and nothing's happened, and it's rotating reactor setup.
Like what Robert say with Nassim Harriman. Yeah. Nassim says that 1 cubic meter of space can produce energy for 100 years on Earth. But they don't realize that the technology is already here. It's ready here for them to use, but they refuse to acknowledge. With the Keshe technology, the technology is already here.
Oh, my issue.
As well.
My issue with Nassim is he either didn't read Buckminster Fuller, or he read and he didn't understand it. And in one of his videos, he says he went and studied and he researched for like 5 or 10 years and finally came to the realization that the two how he got the vector equilibrium, that it was the model of the universe, and then he modified it and added some things on it, and he got the perfect model of the vacuum space or something. Buckminster Fuller laid that out 70, 80 years ago. If he read it and understood, he wouldn't have to spend 10 years discovering something that was already discovered.
Yeah, that's what I'm thinking. The technology is here, but they refuse to acknowledge at all. They say that for 100 years, Earth don't need any power anymore. That is Keshe technology, and they say the best and cleanest energy is the one that produces itself. It's Keshe technology. It's already here. It's the cleanest energy supply, but they refuse to acknowledge. You understand? The cleanest energy is the one that produces itself. It's Keshe technology. Acknowledge it, and we can step forward after this.
Hello, can you hear me?
Yes, hi, Mr. Keshe.
Am I back again? Better, yeah, we have to increase the bandwidth. The problem is not a problem. Nassif is trying to bring a lot of people works together the way he understands it. But in the process, he's denying his own mistakes. And I met the guy in person for 2-3 hours. And my conclusion was, at that time, that is a waste of time. And then what we've seen and the things he's done and he's doing, he is connecting a lot of things together which are not relative at all. And in so many ways, he's trying to bring gravitational field work as part of his work, but he doesn't understand it. And don't forget, Nassim has no education. He's a self-taught. So he draws things on himself. He calls himself a doctor because he said, I studied enough to be a doctor. When we spoke with him, I sat in the room in Liège, 2-3 hours. At that time, I didn't know who he was when I met him because it was organized for me to meet him. And that was the time when he received the prize from Liège University, and they found out it's a fraud. They asked for the money back and he can't pay them back. He said, that's an habit. The prize is received from the university. Some of his work is good, some of his work is totally irrelevant. And with it, he has caused a lot of problems for a lot of people who do the foundation work. But he draws from reading things the way he understands, like all of us do. And he's used a lot of the book number 2 and number 1 on the basis of his work. Because he came, they bought 2 sets of it, as I explained before, and he is very much the way, what they call it, Stephen Hawking came up with a formula for a black hole in less than 3 weeks, from the beginning of July to end of July, to present something in Dublin. And the physicists who attend the meeting says it didn't make any sense. It was just jargons of numbers. And we had to accept the formula because he was saying and it wasn't acceptable. So we got to see how he comes up with something at the end. He might bring us a lot of good things, but at the moment, he's refining his work, as I call it, and it's not acceptable in any shape or form by people who analyze his works. I haven't read any of his works, so I can't pass a comment. But the people who read it or followed him, one by one are walking away or trying to see what he comes up next. It's the same with us. But his work, it's another thing we got to read and see. Maybe one day he come up with something, but at the moment, he's mixing a lot of people's work and half-cooked, and he's trying to come up with a solution. And this is how we improved in the world of science. But Nassim is going a bit too far this time, but it's his way. Because more and more people are looking into his work in detail and does not create a continuous linkage. And it doesn't make, some places I was told doesn't even make sense anymore. But we're going to see, maybe in the future he'll come up with something. In respect, going back to the connections where we got lost, these bends which Armor has created is one of the best solutions, flexible solutions. But as long as you don't open the spring, it seems to be a perfect solution. We are considering it now in production in the layers by layers, that we don't need to twist the wires, because twisting the wires is causing problem in manufacturing. If we can produce such a thing, and it can be done, that we just spring them in, it has a huge advantage. But the only problem is if it comes loose by temperature, one doesn't follow, or if we use a slightly different wires, it will affect the flow of the plasma. So we don't know. We're going to test it. I think the Innovation Center, if anyone is online, has got to test it and see if their flow is the same.
I was trying to consider that and wondering whether the flow of the plasma would go like on the outside part of the coils and wires, or would it tend to flow sort of
It
inside?
flows internally. It flows inside.
You mean inside the wire itself or inside?
Yeah, inside the coil, inside the free space and the wire.
Mm-hmm.
This is
So when
this
it's
is
connected with that little coil, like the Armin coil connection, then there's actually plasma inside that coil, and I guess some outside as well, but it's mostly contained inside the little.
It's a mixture of both. You don't lose anything. It's just one of the points we have to consider is that if we use a slightly different thickness of the coil for connection in the springs, would that affect us?
Would there be a gradient there? Is the thing, I guess. You don't want a gradient. You want the plasma to flow freely between them, like.
No, I don't think so. It doesn't look like it, but we got to see. The other thing you were talking about, the aluminum, the nearest way we see with aluminum is the firing. Firing the aluminum for nano coating seems to be one of the best solutions.
Does that
unless you move into titanium?
Does that give a white coating, or what would that look
Yeah,
like?
don't realize what the coating means, the color. The color is what is not absorbing what gets absorbed. Yeah, it means a very weak absorption, plasma absorption, but it still works on the nano. How do you make a white color? Black is the total absorption. You still create a nano, but a very low absorption. Aluminum is a very low, what do you call it? Low nanostructure absorption rate. It means the gaps are literally huge. If you, let's say, on a copper, if you even look at your copper nano coating, it's not black, it's a brownish black, especially the first layers, and the copperish brownish black. And if you put your nano coated wires in high temperature, you see different colors on the nano layer. When the copper melts inside and it glows internally, you can see the copper inside. None of you, I think, have tested this, but we've seen it. If you put a piece of copper wire which you have fully nano coated and keep a torch on it and let it go at a high temperature, you see molten copper through the material. It glows inside. Copper melt more. You see molten copper, and then you see different colors of the layers. So the ones who give us a black nano coating, it means there are more layers, more fields absorbed. So when you create the nano coated like aluminum, it means the gap between the nano structure is very wide. It has a lot of advantages. This is maybe tomorrow we discuss this. When it's black, it means the layers are very compact and everything is absorbed in the spectrum. When it's very wide, like aluminum is white, it means a lot is not absorbed, only on bandwidth of the white. What is not absorbed is reflected. So maybe if we nano coat another material or composite material, we get different colors. The colors will give us the bandwidth of the nano layer gap, which is a way of dialysis. Huh? Anything which goes through the white nano coated aluminum have these properties. The ones which go through the nano coated of, let's say, copper with so many layers is for this purpose. We can use these nano gaps as a gauge now. Because I discussed this one with Ali was it last week, that when he nano coated his batteries only with fire, and he said it's going to change to titanium when he receives them. These colors, it gives us an indication of the spacing of the nano layers. And a wider spacing, it means exactly what it is. Black spacing, it means it absorbs most of the field strength. So it's another tool. A lot of people go to it and they say it's white. It's still nano-coated, but there's different spectrum. The gap is so big that you cannot absorb all the fields. It's like you're having a 1 centimeter by 1 centimeter cubes. Now you have 100 centimeter by 100 centimeter cube, the same light. Less is absorbed. So this is nothing wrong adding to the knowledge.
Can I show you one thing, Mr. Keshe?
Yes, Mr. Ahmed Golin. Is that the, what do you call it? It looks like a marshmallow burnt.
Inside was a coil, aluminum coil. So when you nano coat and actually vapor nano coat, so it creates very good solid actually structure, but it's nano coated. Now you can put the GANs on top of this.
So wait a minute, Armin.
What is that white you have there, Armin?
It was aluminum coil.
Aluminum coil, not hooked up to either end of your wire, just in a coil.
Like there is a middle, correct? And I winded aluminum coil, and on top I winded brass coil inside, and this one is copper too. So 3 coils inside, actually aluminum, brass, and copper.
And then
so the white is the aluminum, which is converted.
Yeah.
But it still stays as a sheet in a way.
Correct. As a paper that. So this is like.
Okay, Arman, can you open it? Open it up. Open the spring. Can you open the spring? Put a glove on, for goodness sake. Don't touch these things with the hand.
Thank you, Mr. Keshe. That's a good idea. Armin did have a glove on for his video that he did recently. So thank you, Armin, for doing the safety precautions.
Just both hands. Become a custom inspector.
Dr. Armin.
Dr. Armin. Okay, open it up. Let's see if the nano coating is inside too, or is it just on the outside layer?
It's like a powder, becomes a powder.
Okay, let's see if this inside, because the inside interaction is where the energy transfer is.
Okay, 1 minute. Okay, this is one wire.
What's this one?
This is brass. And it's black, Mr. Keshe.
Yeah, but where is the aluminum?
Aluminum becomes this powder.
Doesn't stay as a sheet.
Doesn't stay, but it becomes all nano powder.
Open it. Let's see.
Inside.
Crystal.
This is the inside look. Oh, this is aluminum. This one aluminum. I'm sorry. Here, this one is this inside one is brass.
Yeah. So the white was aluminum, which you just opened.
Yes.
So now you have a nano-coated aluminum sheet.
Yes. Now you have nano.
But is it all the way nano-coated? Arman, can you? Okay. Oh, you use the wire. Can you use a aluminum foil which everybody uses? Use the brass, put the GANs and put aluminum, and then put the copper wire on top, then the coated copper wire, and steam it and see if the aluminum disappears.
It is disappearing here. It stays, but if I leave it enough in the caustic, it will disappear.
I know it will disappear, but we want to know if the film disappears or it still keeps its layer inside.
No, it will keep the layer inside, Mr. Keshe.
Yeah, well, because I tried it, it's gone. I'm surprised you got aluminum. it wasn't long enough. Otherwise, the wire would have gone too.
No, it was here. This one is brass, and
Yeah, the aluminum wire would have gone if you would have kept it in a longer in the caustic.
yeah. But look, this aluminum is more thicker.
He's like a magician. He says, "Oh, this is what I made earlier before."
Here, this is the thickness of normal wire that I made.
You know, it lost a lot.
It lost a lot, but still, it's nano.
It's created this sort of aluminum crystal structure around the.
And it was holding very good, Mr. Keshe. So you have all three materials nano-coated. All you have to do, put the cans on top.
The whole thing.
Yeah, but the question is, just hang this aluminum nano-coated somewhere and see with time, will it disappear or would it stay?
1 minute.
Hang it somewhere.
Mr. Keshe, I have some aluminum that I did a while back, and I sprayed it with cold caustic, waited about 15 seconds and washed it off, and it looks pretty nano-coated to me.
Yeah, but does it stay on or would it go? Because I have experienced that after a while, just the whole thing disappears.
I
The
can show
process
this.
carries on.
Here, this is split capacitor. Again, in the middle is a.
Arman, can you send me a copy of this split capacitor, please?
This one.
Yeah. Just send a picture of it to me. I need to send it to somebody to see it.
Okay.
Yeah, but the thing is, to my experience, especially if you use aluminum foils, when you do your test, it's still there, and after a while, it's not there, it just disappears, evaporates. But one thing, aluminum GaNs, the white stuff you get at the bottom of the caustic, is one of the best gases for transmission.
Transmission of what?
Plasma, if you use it inside your coil. If you add a little bit of aluminum GaNs, you get a very good field transfer.
Aluminum GaNs or aluminum nano?
GaNs and aluminum GaN. You know, when you make your coils and you use like a copper oxide and whatever, if you add aluminum GaNs to it, you get a better result.
Yes.
More powerful batteries. The reason being, the gap is big, it stores more energy.
Yeah.
You understand?
Yes.
So if you add aluminum GaNs, we try to teach this tomorrow as well. But I've mentioned this before, a lot of people forget. If you add a bit of aluminum GaNs to your caustic, to your GaNs mixture for your batteries, due to the large dimension of the GaNs, the softness of it works on a different dimension of the strength, you create a bigger gaps for storage. It gives you a very good storage capacity in the GaNs level. This is why even in some of the batteries, originally they used to use aluminum. I came across this by experience when you put, if you open like a Motorola, all Motorola batteries, which on the telephone, and just put it in the caustic, you'll get an amazing material as a whole package. If you open the circuitry and just get the foil, it's got like graphite in it, it's got copper sheets in it, and it has aluminum foil in it. Separation foil is the aluminum. That GaNs is an amazing GaNs when you get, plus the copper sheet, which is already there, nano-coated. if you look for a powerful storage as a plasma capacitor, you need to put aluminum in it, aluminum cans.
Actually, I smashed some batteries, Mr. Keshe, and used caustic process and washing afterwards. I keep it. It's like a pure material. It's carbon.
How's your 3D printer going?
Oh, today I printed the first detail with Robert. Actually, he helped me to set it up. One bolt.
Did it come out, Armin? The bolt?
Here, Robert.
Oh.
Yeah. Can you share a screen?
Okay, just
Hello.
Let me.
Yeah, stop the screen sharing.
How do I stop it? How do I stop my screen?
I can stop it.
Yeah, go ahead. I lost my.
Screen. Okay.
I lost my screen.
And now we go back to. Just a minute, Armin. You should be on there now. Just gotta put you on.
Hold on, where is?
That should have gone off. How come it didn't? Oh, okay. I have to actually select something in order for it to go off. So I'll try something like this, and that should quit yours. Oops. Quite the way I expected. Let's try something different here. Let's try this square. Sure. There, that killed it. Okay, now we have to get Armin back onto correct screen. There he is. Oops.
Armin, don't forget that with using Magra power supply, you don't have worries about your power unit.
Okay, we can finally see the screw there.
Oh, it can be serious.
Yeah.
Did it stick to the paper?
Perfectly.
You don't need a tape then anymore.
Yeah, don't need it.
Use a paper. Nice.
Yeah. First one.
Good.
Tomorrow it starts to work 24/7.
You gotta learn the programming of the design.
Yeah.
That's the key to it.
That's what we hear working a little bit in the background there, that little whiny kind of noise, Armin, is that right?
Yeah.
Doot, doot, doot kind of thing.
No, it's not from me actually.
Oh, okay.
It's not working anymore. It stopped.
Oh, okay. I see.
Yeah, Mr. Keshe, I just looked. I've got a battery from at least 2 weeks ago that still has aluminum nano-coated foil in it. It's really flaky, though. If you touch it, it almost flakes off onto the ground.
How did you nano-coat it? With caustic or fire?
With caustic. I sprayed it on, waited about 15 seconds, and washed it off.
Yeah, it disappears. This is a problem. This is a problem with that. It's not a problem. It's the way the molecular structure is. When it changes to nano, the gap is too big. It's too big for it to hold on.
Yeah, but if you have
some way, right?
Mr. Keshe, if you have two layers and it's between, actually it's holding on.
Yeah, but how are you going to nano-coat it?
Your nano-coating.
That's why I asked you. That's why I asked you to open it up, open your capacitor up.
Yeah,
I wanted to know if the inner side is weaker or stronger or is the same.
Actually, inner side, if you're looking at it, it's black. Only the aluminum is like a powderish, but it holds between the springs. And it's not falling. If you're shaking it, it's not falling.
Yeah, but that's what it says. After time, it's nothing there to hold it. Because part of it adds up with the oxygen to create molecular plasma.
Right. So what if you had
And then the separation is too weak to hold. It becomes like a powder. It separates.
what if you had a tube around the copper coil, either a copper tube or a plastic tube, maybe shrink wrap even, and that would keep the oxygen away from the aluminum and keep it all, inside the coils of the outer copper coil.
It's impossible. Then you have to vacuum seal it.
Yes. Or just seal it so that when the aluminum expands to a certain point, it can't go any further. It can't powderize itself and it can't be more oxidized because all the oxygen would get used up in there.
Let's say this is almost 7-8 days that it's drying. Before that, maybe another 3 days or 10 days.
Guys, I just got a report for you, just coming through. That on the 25th, we will receive the certification for pad and a pen, EU health certification.
Yeah, Mr. Keshe,
So,
they are asking for that US certification and EU certification for the
we don't need to supply to nobody. We have it. When we say we have it, we have it. Why do we have to supply to anybody? It's only applicable to the Keshe Foundation, Italy, which has produced it. You don't need to produce it. If you have another manufacturer in Italy under different name, they have to get their own certificate. You can't transfer certificates.
I know, but the distribution center is asking if we can.
No, it only applies to us, and we have it, and we receive the certification for it. The test results is the same. It's not, because you cannot transfer your CE certificate unless it's a common denominator factory. Even in the different nation, you have to receive it from there. So when we say we have it, we don't need to supply to no one. Anyway, it just came in just to inform you. So
That seems like good news for that's for the health pens and pads too.
pen and the pads has been certified. Yeah, on the 25th we'll receive it just now.
And is that a special? That's not a CE. Is that a different one, like a health?
It's a health seed, yeah. It's a health certificate.
Okay.
That is considered as a medical equipment. We can't sell it as just like sports recovery anymore.
Right.
It has restrictions on advertising. So a certificate too, as far as I know. So it gives us certain freedom. We can put it on websites or whatever, but maybe we can show it on a health section. But what is this? It can be, what do you call it? It can be introduced to medical doctors to prescribe it. That's the advantage with it. Doctors can prescribe it as a medical equipment.
Right. Well, that could be very good.
Yeah.
This is something that could be introduced to the medical profession.
Yeah, it can be introduced to medical profession, but they don't like it because it means the patients don't go back, huh?
Well, there's no big money in it. That's right. But this might be the way that they'll be forced to go by governments in the near future, because the governments are going broke trying to pay for all the medical costs. If they have a way that they can get people off painkiller drugs and have them do their own pain solving their own pain problems with pens and pads, it might be enticing to governments to go that way.
We are working on the background, very, very remote possibility for the first Keshe Foundation hospital facility, which if we can get it in the next few months, it's very remote possibility, but it depends how many systems we can introduce more and more, that it can be clarified. It'll be the first place where you can go and literally be treated totally with the plasma technology from the foundation.
Sounds very interesting, actually.
It'll be, I think, months away, but these things need negotiation. So there's a possibility that we might get a position where to be given a hospital or a ward of a hospital that only that process can go through. We'll see. We'll see. Anything else? Anything new?
Keshe, I have a question.
Yeah.
I just had this idea on when we're making the.
Could you speak up a little bit there, Robert, so we can hear better?
Right. How about now?
Thank you.
Okay. I was thinking when we're making the capacitors, if we when we're using the center wire, a nano-coated wire, and we're wrapping it with an aluminum, nano-coated aluminum foil, can we put other nano-coated wires of different materials within the same winding wrapping of the coil? And if so, if we would give any benefit?
You're
And
guaranteeing a potential difference.
would this be something useful? I just thought of this idea just when I was started modeling. And then they would be dipped in a, I guess, in a container of GANs left in there or taken out.
The question too, would it be to draw plasmatic energy out, or would it be to put plasmatic energy in? They look like fuel rods in a way. Do you insert the rod to increase the flow through the coil, through the spiral, or slow down the flow through the coil, perhaps?
Yeah, and I think this can be wrapped with a coil on the outside also, like a split capacitor. I don't know, I was just thinking about it, so I'm just throwing it out there, see if there's any use for it.
And would these wires go all the way through to the other side, like, or would they just go through part way, do you think? How would you say it? Would they have a connection at the other end, a common connection somehow, or are they just, do they have
I was thinking,
a connection at either end for that?
if they're different materials, I don't know if you would connect them together on this bottom. I don't know.
Hello, can you hear me?
Yes.
Yes, sorry, I got kicked out. I lost my net. You were just showing this and you say you put different pins in.
Yeah, the idea was to, when you're wrapping the one nano-coated wire with nano-coated aluminum foil or other material foil, could you place other wires of other nano-coated materials within the same wrapping, and if that would give any benefit?
Yes, you can do. We've done it a slightly different way, but then you can put each pin with another pin in series or in parallel. This creates a bigger flow in the plasma. Yeah, and then depends how you reconnect to the center, which one you consider to be the center. and how you connect to that. It becomes multiple battery. We've done that in a couple of tests, and it's the same.
Would you connect them at the bottom or just on?
No, as a normal battery, it's a center pin.
Okay, so each one would be a individual center pin.
Center pin, yeah.
Okay.
It boosts the energy, but you have to try to see how you can. If you connect in the diameter from center out, then it becomes like a nano layering. It's a multiple layering.
Okay. Also, last week we were discussing an idea of putting the coils in a pattern like this, but I think I saw in the 94th workshop you said not to bring the coils too close together. I was wondering what would be your comment on some kind of a...
No, when you put these things very close, you close the circuit. There is no, you dictate. When you want to dictate a position, you can do this. But when you just let you open it up, then the plasma decides.
But putting them sort of oriented towards...
You see, it's
center.
impossible. Let me tell you something. It's more or less impossible to make this diagram in reality. It's a beautiful picture, but to build such a thing is one of the impossibilities, practically. This, to hold things in such an angle, and at 90 degrees, you got to make like a triangle pyramid, and then and place it on a triangle pyramid and fix it. And if the weight of your center gravitational coil, the blue one, can hold in that position.
Well, if you could, would this be better or worse than the traditional?
I don't know. I don't know. I can't tell you.
Okay.
I don't.
And I guess another variation of this we were discussing was vector equilibrium covered with coils on the outside.
This what you show. This what you got on the drawing now. If you can make it in reality on a six-sided body with a gravitational field, the blue one in the center, and you could keep the spacing, you will build an amazing box. Move the gravitational field which are on the corner into the center as normal. I always say, when you open a pattern, when you bring something up, I teach. You heard of the hologram? You heard of a zero-time transportation?
I know about a hologram, but
Okay.
not really.
If
Hello?
We've lost Mr. Keshe there. Hello, Mr. Keshe. Not hearing you right now. At the critical moment, you were about to tell us the magic formula.
The secret.
Robert, this is Denny.
Hi, Denny.
I think he was indicating that the blue gravitational coil would fit inside the red one on a perpendicular basis. I'm not certain that's what he was thinking, but I
thought he said bring them in closer to the center, but maybe I misunderstood.
Yeah, my understanding is he was going to make them perpendicular and the blue inside the red, but I don't know. Can you?
Hello? Hello?
Yes,
Yes.
hello, we hear you now.
Sorry, I came back. I lost the net. Yeah. If you bring the blue ones in the center of the red, the same as the one which we've seen
okay.
with Ali, yeah?
Similar to these?
Yeah.
Towards
Bring
this.
it to the middle.
Okay.
Yeah, bring it to the middle.
Okay.
If you bring the blues in the center of the red, the same as the gravitational, don't forget when we look at this blue and white, we consider the blue to have its own gravitational center and the red to have its own gravity. So when you show me these pictures, we consider as double coil. The red ones and the blue ones, yeah? Okay?
Okay, let me...
Yeah, put it back in, flat.
Give me a second here. I have to...
Robert, power unitները ոնց է սարքած, մեկը մեկի մեջ, ոչ թե
Hassan Ahmad, wait, just wait.
I got it. I'm just trying to... Well,
This guy is a 7-month-old. Kamas, Ahmad. Wait.
Kamas. This way or flat?
Both ways, flat. Just turn it in as the same as the red. You can put it at 90 degree, no problem. But it gives you a different result. But if you go now, turn it 90 degree to be the same as the red, that it sits in the center of it.
So
This
either...
way,
կապոտ բան քոյլը ֆրծվու։ 98 ֆրծվու։
Okay, so you want them to be on the same surface?
Yeah, on the same
yes, on
plane.
the same surface. Yeah.
Okay, okay. I thought you wanted perpendicular to...
You can do it perpendicular. Perpendicular will give you a different result. If you do it perpendicular, yes,
Okay.
I tell you what to do afterwards. If you put all of them the same as what you've done now, yeah.
Okay.
Do the others. Okay, if you make a box like this with all of them, in the center you create what we call zero-time transportation unit.
Okay, that would
What
come
you
in...
receive in the box, and if you can control the gravitational magnetic field of both the red and the blue, and all at the same time, you can put something in the middle, exactly in the middle of the box. And by changing the direction of the way you are doing with the blue one now, you can dictate the direction of the transportation of the element into any position in the universe. This is known as what you call one of the ways of teleportation, or you call it what we call magnetic transportation, zero-time transfer of elements. You create a box which is in balance, and by changing the direction of one of the blue or the red, you dictate the direction of the flow of the material in the direction you want to send it to. But there is a second part to this before you can complete it. You can use this for even transmutation of the elements from one to another.
All right.
If you want, for example, in the center, you put aluminum and you want to change the aluminum, let's say, to copper, you need such a system to be able to transfer. What this does now creates a box of energy, and in what you transfer between the blues and the reds dictates what energy goes in the center that to increase the magnitude of that element in the middle. This is how your parotid gland works. Individually, and then what you do, if you create a balanced field in the red, you create what is known as a black box transportation. You can put whatever you like inside it and transport this unit anywhere in the universe. What you get out of it at the end point is exactly what you put in. No condition in transportation time can change. It's like a Tesla box. What do you call it? What's the name of it we use? Faraday box.
Faraday
This is
cage.
a Faraday's cage, yeah. This is a maglev Faraday cage. It's a maglev cage. Yeah? In the future, I'll teach you more how to do this. If you go down,
With these,
there are different formation of this you can build.
yeah.
Okay?
Would the coils be double coils, each one of this?
All the coils have to be. You got to understand the reason why we use double coils. The double coils dictates the continuous gravitational magnetic field in every element. You never work with the single coils on their own. You always work with double coil, which means the environment they create is the environment of a plasma. Single coil is a matter state. When you put a double coil, you transform it into a plasma state coil. You understand?
Yeah.
It's a big difference. Why are we upside down now? I'm just getting dizzy. Blah, blah.
Just give me a second. I'll position this coil.
This is a transportation system. And you need it. You have to, you can devise different ways of it to do it. You can do the one you showed before with the 4 in a triangular shape. You can use that kind of things too. But this is one of the most safest way of transportation because the uttering the red ring will create a condition. You can create a condition of the zero transportation gravitational magnetic field in respect to the environment. So the transportation time, the interference is 0. So you travel with the speed of the what you create in the blue ring. And you can go thousands of times faster than the speed of light by order of magnitude. Because now your box is sealed. It's totally, what do you call it? It's totally, it's not shielding, but is equal to the environment it transports itself through. So it's always a 0 friction. You never see it. There is a version of this, I'll teach you later on, which creates a spherical long. If you take, now when you finish this one, I'll tell you what to do. Finish this job.
We don't need these 2 coils, right?
You had 6.
Really?
Okay. Keep them, you might need them, but anyway, they're there. You can replicate and delete them.
Okay, let me save this.
Now, this is a box, yeah?
Well, let me save. What should we call this?
This is a transportation box. Just call
transport.
it transportation box. Okay. Now, get the 2 which are on the sides, not on the top. The 2 on the sides. We just see the red off.
The 2, these 2?
Yeah. And elongate it. If you elongate it, if you can elongate it.
Elongate the coil?
No, the distance between them. Increase the distance between them.
Between going outwards,
Outward, yeah, both of them.
how far?
As far as you like, make it like a ray.
There.
You can make this like a, what I call like a cigarette. It becomes elongated cylinder.
But so there would be a rod or a pipe that
Yeah.
this would be mounted on, right?
Yeah, yeah.
Okay. Let's see. Okay, I'll add a cylinder, maybe clear cylinder.
The red has to move out as well.
Oh, the red also. Okay.
If you can expand the green,
Expand the green, make it larger.
yeah, just to become cylindrical between the two
Oh,
ends.
no, not really. Not really quickly like that. I would have to
Restructure.
model it.
Okay. Anyway, if you go, but this has become like a array. But this box you have in front of you, if you go back to, you can do that later on. But the box you have, these are transportation units
So it
and
basically,
transmutation units. So you create a balanced environment, and whatever is in that center, you can change from one element to another by changing the gravitational magnetic fields of the ring, the red or the blue ring on the total box. So you can go from, let's say, one heavy element to the lighter using the blue rings, or you can go, what do you call it, from lighter to heavier using the blue, and from heavier to a lighter using the red rings powers. So you drain the plasma by the red, or you increase the mass of, that's when we speak about the mass, is gravitational magnetic field. You increase the element from one element to another. These are transmutation boxes of the universe. This is where, for example, when you're short of one element, you start with hydrogen and then you just do it. It's like a fusion boxes. But you add both gravitational and magnetic field at the ratio that the element inside can receive, and you compact it. There are different formation of this used in the universe, totally different formation. You have, what do you call it? You have multiple ones, like between the top, for example, or the sides, use a number of rings, like 4 or 5 of them. You know, like where you have now one on one side, you use like 4 or 5 of them. So you create it elongated, yeah. So then this system at the end is 1, but on the sides could be 5 or 6.
of the same size stacked together, or like
Yes,
larger
of the same
ones?
size, of the same size.
Same size, okay.
So you make it cylindrical, and so you can produce transmute elements from one to another. This is one of the cornerstones of production of materials. You do it yourself by adding the plasma to it. If you understand this, then maybe if you extend the knowledge, this is how the neurosystem works. The neurosystem is built on this kind of structures. So if you put where you just put the blue, put 6 or 7 of them next to each other, or 3 of them next to each other, but you still keep the ends the way we're looking at the ends. Then you make it cylindrical and cubical, and you produce transmutation and transportation units. And whatever you transport in this box, on the other end, when they receive it, is exactly the way you send it. So if you send a hamburger in this box, on the other end, they receive hamburger. You understand?
So the receiving station or box would be like exactly the same type.
Itself is the it itself transmutes at the point of arrival. You don't need a what do you call it?
Receiver.
A box on the other end to transform it. You
So
understand?
it sort of projects to that.
No, it transports. It's a box. It doesn't project.
Does it actually move though, Mr. Keshe, or like does the box go to the destination?
The box goes itself. The box is the carrier.
Okay.
You understand? You cannot transport the transmutation of the element, the transportation of element. Like they say they want to transport an atom or a cell, they've been successful 95%. They cannot do it because they never consider the gravitational box. But this box is both gravitational and magnetical. So it holds its position, and in the time of the travel, because you choose higher order, the maximum order of the strength on your rings, the box arrives as it is. At the point of arrival, they open it. The opening is that you change the gravitational field of the box, the magnetical field, so the box opens up. And whatever is inside it appears at the way it was shipped, because internally, does not change. So you send a spoon, you get the same spoon on the other end as it is. You don't send the field of it. You cage it, you transport and use the structure of these rings as a transportation holding to the point of arrival. Because your box not only holds the containment, but it can change accordingly at the point of the distance of arrival and departure. So it can create its own gravitational magnetic field of the destination point, and then when it opens up, but it still carries the structure of what's holding inside it. These I teach in the future these are transportation systems.
Better than levitation systems, huh?
It's no levitation. It's a full package of its own.
Would it work for human transportation as well? Or
of course. Of course. Of course. These, if you learn in the future, when we do the full transportation teaching, they can even cross through the wall of the spaceship, because the package is that way. They take the shape and they continuously change to the position where it's pre-structured at what field to open up or to stop moving. These are the transportation units, and transmutation depends how you want to use it.
What is this?
If you turn this sideways, and then go back into the teaching of last week and stack it up, these become perfect operating system for operation without intrusion.
I didn't understand that. Turn the whole unit?
You mean to rotate the whole thing so the red?
No, now you made four red rings. Put them next to each other. between the two outside ones. Just put them next to each other. Along between the two wide ones you opened up. Do you have 4 rings now or 3 rings? Put them next to each other, side by side.
Here, on the outsides?
No, between the 2 red rings you put apart from each other. Now, the rings which you stack over each other, put them next to each other. Like when you look, you see 3 rings next to each other and the 2 rings at the end. Just slide them to the side.
These packs.
Yeah, these packs here.
Slide them or copy another
Slide them or copy paste, whatever you do. Now we see 3 circles. Here we should see 3 sets or 5 sets or whatever. Yeah, that's it.
Like that.
You always try to work in 3s. And now move to the other one, to the other side here.
Let me see if I got it. I just moved those. Okay.
If you look inside the structure of the, what do you call it? Parotid gland in such a small size, it has this structure. It has exactly this structure, where at that point immediately transfers phosphorus, calcium, or potassium, and then it releases that energy pack to where it should be. Because like in, what do you call it? In let's say in North Pole, as I explained before, people have a limited food supply and they don't have the full spectrum of all the materials they need, but the body of the Eskimo and the man in Africa or in, let's say, Egypt, carries the same kind of minerals. We don't have a different blood test for a man in North Pole or in the South Pole or in Africa or in Asia. Because this box transfers everything to what is needed as an energy pack at the point of delivery to give information to the brain. It's not a box which copies. The box creates a package of information which the brain understands and replicates its energy transfer in the neural system. And then at the point, let's say in the heart, it replicates that. Parotid glands are replication boxes of plasma. And they are exactly like this. When they open them up, they see such a structure. Now you have a very long, you have, what is it, 7 of them next to each other. It becomes a very long tube.
Mr. Keshe, we had a question about the plasma capacitor batteries earlier, whether or not we would see a voltage on the, or maybe a millivoltage on the voltage detector, or if that was even necessary because...
No, you got to try. Sorry, I've got the feedback. You have to start walking away from the voltmeter. You will not, especially when you start making a lot of plasma batteries next to each other, your voltmeters are useless.
Okay, yeah, that's what I had thought. Also, the star formation with just one of the coils on to the bottom outside 3. Those coils need to be the same height as the center of the bottom stacker, right? In the center?
I don't understand.
Okay, the 3 outside ones, if you just use one coil for the 3 outside in the star formation, and you've got 2 stackers in the center, should I raise the level of that coil up to the center of the bottom stacker that's in the center? Or could it be at the level of the bottom or the top, or the level doesn't necessarily matter?
If I understood correctly, you're talking about the positioning of the stackers?
No, it's so the outside three. If you have to have them raised up a bit.
Yeah.
So I have them at the level of the center coil, which is on the bottom stacker. Or does the height of the outside three not matter when it's just a single coil?
I don't understand. I don't understand.
Really
Robert, maybe you can make a picture or something. It's very hard to understand. First of all, it's hard to hear your audio because the microphone is scratching, making a lot of noise in between. And second, it's hard to visualize what you're talking about. Maybe a picture or something, or a description of some sort might help.
Yeah, I've got my video on.
Just
If you can try to.
Can you?
Can we go, Robert, while you are working, we go to his video and come back to you later?
Yeah, Rick, can you turn me off? I can't find my. Disappeared again.
Oh, Rick, you gotta play God. Appear and disappear.
Yes, I've got to select something here, and that cuts him off, and then go back, stop my share, go back to Robert, and spot his video. That should do it.
Okay, show us.
The height here on this one, on the outside, should it be at the level of the center of the bottom stacker, or just the height?
What is this? What have you made?
But you said we.
He's using 3 center coils, 3 coils as a side coils, and 6 as a stacker.
Robert, can you hold the video steady because we can't see it when it's moving around? Okay, thank you.
Yeah, sorry, it's really hard on just on a phone. So.
Right. Okay, that's where.
Yeah, he's using instead of stackers just 3 coils, and then he's using 6 coils in the center as a middle part.
Yes.
I don't know how you're going to do this, but I don't know. You gotta find out. I can see what you've done.
Okay.
I don't know.
Height to have these at. Okay.
I haven't got a clue. I've never seen such a thing.
Okay, I thought you had
It's
said.
good. Try it. Try it. There's nothing wrong with it. Just try it and let us know.
Okay, yeah, I thought you had said that we could use just one coil if we wanted to for the outside 3.
Yes, but then you use 1 coil for the top 2, or 2 coils stacked the problem. Now you're using 6 coils.
Right. Okay, I understand.
So, yeah, I don't know what it'll give you. It's a beautiful design. It's fantastic. But you see, you have to make sure the shape of all your inner coils and outer coils are in the same direction as the rest.
Yeah, it's not complete. I also have more batteries I have to make and so forth. And then I've got to change this now with this new information as well. I've got the bent connectors that Armin had.
Have you powered it yet?
No, not yet. I'm still waiting for some batteries.
Power it and see how you feel in it. Do you have a single plasma battery anywhere?
Yeah, several of them. Not right here.
Just connect it on. Just connect it on. Make sure all your wires are nano-coated and see if you get any feeling about the environment.
Oh yeah, I already do get a feeling about the environment. It's I can feel like a breeze around it, 3 or 4 inches away. These are all. I'm sorry. There we go. These are all the capacitor batteries that are hooked to the top. And I've got Alex beads. I don't want to touch it with my bare hand.
It's a very beautiful system.
Thank you. But so yeah, but I can definitely feel it. Almost feels just like a breeze at first, and then starts to tingle. And so I know I need more batteries for the whole thing in the entirety, and so I'll be doing that tomorrow. But
move the tree up and down and see what feels you get. Now it's opposite the other way around. If you can move your 3 units on the base up and down in respect to the 6 one you have, and see what you get. If it changes anything better or worse, or what fields where.
Okay.
Very nice. That's fantastic. Thank you very much for sharing with us.
Thank you as well. All right.
Thank you.
Thank you, Robert. That was much better than trying to talk about it. way better. It was great. Thank you.
Okay, are we anywhere with Robert? Robert, work on it next week. Show us this. But anybody who makes such a system, try with a nanomaterial or a GANS first. If you make such a tube, if you decide to make such a system for transmutation, try with a GANS of RAC-CH, and certain amount of it, and see if it stays visible or it comes out as different thing when you fed the system. Yeah, I'm getting there.
Mr. Keshe, would you also put 3 sets of coils on the top and bottom, similar to
The same. You have to keep the box exactly the same, all conditions. Yeah.
So it's an elongated box with 3 on the sides, all
3
around.
on the sides and 3 on the top and the bottom.
Okay, got it.
So because this, the cube you showed, the triangular one you showed first, it's very hard to build. But if you can build it like on a page and hold it on the 3 sides and the bottom, this gives you a different structure. But these are all transmutation and transportation unit. Transmutation is done in conjunction with the field in the gravitational field or a magnetical. Transportation is when you use only the magnetical. And with the gravitational, you hold the content in the same all the time. This is how we work, how our body works. We stay human body even we go into the moon, or we go to another dimension, another conditioned position in this galaxy or in this solar system. Our skin does this automatically. So now, for the first time, you have built what I call transmutation and the transportation unit. It's beautiful to see this.
Would the connections be all magnetics connected to each other in
Of course,
series?
it has to be. It has to be. You decide. As a controller, you decide how you want to strengthen it.
And how do you...
I told you this year we go totally into plasmatic process, and this is the first one of the first. There are several versions of this. This is the first version I've seen now. As I always say, you come up, I'll show you, I'll teach you further. These are transportation transmutation units, and it seems that we are all coming together in the right place for a lot of things. So, for example, you have let's say egg and you want to make it to a chicken, you can use this unit because the basis of the egg and the chicken is the same. You can see and watch your chicken because the egg become chicken. If you know how to control all the coils accordingly to what it needs to be done.
You would control the coils
Every coil,
individually?
every set, yes. Inside and outside, gravitational and magnetical.
So you would have to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 controls.
Sets. Yeah. Yeah, it's very easy. I'll show you how to do it. In a way, Ali is working on one, but he's in a very crude way. We explain it when he finishes system.
Also, these end ones, the two for
Everything, of course, yes.
should be
You
also
can
3,
open
right?
one end, yeah. You don't open, when you open your box, you don't need to open the 6 along. You just open it to one of the ends.
And the end ones should be also a 3 set
No, one
coil or
set is
single?
enough. No, no, one is enough. It's a cylindrical.
Okay.
You change the shape depending on the size of the material if you don't want to use a huge coil. In the coming time, you use the same structure for change of, let's say, close operation for the heart surgery. We did a test last week where we put a guy with a cancer in a system, and within less than 10 seconds, all the cancer pain disappeared. You couldn't touch the stomach, but within less than a few seconds, he could push his finger right through to his stomach. He says, I have no more pain, it's gone.
Wow.
The cancer pain is totally gone. But we use a very specific structure to do this. As I said, we are negotiating. We hopefully will receive authorization for the first Keshe Foundation hospital.
Well, I could
And
use.
these we will introduce totally new systems, unknown.
I could
I'll
use.
tell you what you can do. Let me explain to you what facility this gives you. You know, you can use like different coils of different position, different strength, just to keep whatever you put inside in rotation. You don't like you have a refrigerator, like you have a suspended system, you have, let's say, a coil inside which continuously rotates. You can create a rotational field for your plasma inside if you know how to use these systems. Let's say you finish building the one half of the heart on the top. You just turn the heart around. You start turning, you turn the machine fields around, and you go to the other part. Or you get the patient inside rotating just by changing the fields without any physical motion. You learn this very, very quickly. People who understand this will develop these systems very rapidly in the next few weeks. If you complete this, we can carry on with it in the teaching tomorrow, because it has to be taught and learned.
Okay, I'll work on that. Just
Thanks very much, Robert.
one last question. Should I extend the faceted shape of this vector equilibrium all the way to here, or put a
Yes.
cylinder?
With one box, yes. Keep all the pictures, then we can show different application of it. Even if you flatten the triangular one you showed at the beginning, you can do with that as well. But those are very, very, very stable, but very hard to control. That kind of shape transportation is extremely hard to control. You can even make a spherical shape of this in a specific way, where you transport as a ball, as a sphere. But the one I just showed you, you have to go into a ray shape. You go without hardly any friction throughout the space.
Can you control the speed of it, or it always
Yes,
travels?
of course. You don't control the speed anymore. You change the gravitational magnetic field according to the position of the arrival. It gets sucked in.
Depends when you want to get there, huh?
Where and how fast and what speed and what transparency you want to get there. We were about 4 of us a couple of nights ago walking, and before that I said to Caroline and our friends, would you like to see a star? Shooting a star. And when we stopped at the point and we all four looked into the sky, we saw a very fast shooting star. And we had a wind of about 100 meters because there were buildings along the two sides. We couldn't see any further. You can do these kind of things. I teach you how you do it. You create packages through your thoughts. And you do the same thing with this. Armin knows what I'm talking about. He's seen it. But last couple of nights ago, not last night, the night before, I showed it again to about 4 people around.
Well, I think we're all eager to learn.
Step by step. As you say, gamas, gamas. Huh?
Gamas, gamas. Yeah.
Okay. Anyway, I've got to go. Carry on with your work. We'll see you tomorrow morning.
Mr. Keshe,
Yes.
this is Denny. Previously, I showed a frame system that makes it easy to move the top two maggrav units in your star formation up and down fairly easy. Would you like to take a quick look at it?
Let's
No
do
problem.
that tomorrow.
We'll do that tomorrow as part of the teaching.
The workshop.
Okay, that'll be great. I'm not in no rush.
Thank you very much. Thanks, everyone.
Okay, thank you.
See you tomorrow.
Thank you, Shalom.
Thank you.
For having honoring us with your
Grandmother, thank you very much.
It's an honor to be with you, Lord. You're such a good knowledge seekers. I wish I could seek knowledge the way you do. All the best. Bye-bye. Bye-bye.
Blessings, Shalom.
Thank you.
See you tomorrow. It's Karen.
Okay.
Thank you very much, Rick. Thank you. Appreciate it.
Yeah, I think we should probably wrap it up for today. Gone on for quite a while here, but maybe there's a couple of last minute comments or questions or whatever we could deal with. Anybody have anything to say?
Rick, can you send me the invite for tomorrow's workshop? I never get one for the Zoom.
For the Zoom, okay, and it's the same Zoom each week. So if you had the one for last week, then it's the same this week. But I can send that to you, Robert.
Yeah, I never get one for the main workshops.
Okay, usually that's posted either on my Facebook or in the a few of the other Facebooks, and also on the forum. And sometimes I miss the Knowledge Seekers workshop, or sorry, the Plasma Reactor group. So I'll try to remember to post it there, and I'll send it to you as well.
Yeah, I'll try to finish this, but I'm not gonna promise. If I finish and I can't attend, I'll send you a e-drawings
Sure.
version of it. Maybe you can, show it.
Yeah, that'd be great. Thank you, Robert.
Okay, thank you, Rick. Thanks, everybody.
Really appreciate it. It was quite
Thanks, Robert.
Quite inspiring to see you working with Mr. Keshe that way. It's a great way to do things, I think.
You're welcome.
Thanks. That was awesome.
Thank you. Thank you. Appreciate it.
Who was that? Was that Karen? Is that who that was? Can you say who you are?
It is the client mother. It's Karen. How are you?
Good. How are you? Can you say who you are? Or I see you came in here and.
I'm actually very excited. It's actually Your Grace. I'm a clan mother, so just wanted to say thank you. I've been monitoring for quite some time and got a lot of copper to do up here at our place.
Excellent. I mean, copper, when you
yeah, we'll be bringing it in.
Copper is.
Yeah, I did a lot of stuff before, so.
All the ancient copper.
And doing some Ormus and some stuff. I'm going to talk to former Sergeant Patty Broussard. Patty was actually the one that set up the NASA communications labs and went through the U.S. Freedom Team and has set up lots of warp drives and stuff before. I think Patty would be very awesome to get in here. And Sergeant Daniel McBullen III. They're part of the Secret Space Program, unacknowledged. And they've got a lot to add in here. So I'm going to see about seeing what we could do to bring them into. This is right up their field, what they do, the warp drives. They've been off the planet, so they would know.
Well, that could be useful to have some off-planet input. Some of us are not quite on planet as it goes anyways, but it'd be nice to have some experienced input, let's say. That would be great. I think that's...
Yeah, we're just in the middle of setting stuff up. Yeah, I'm setting an embassy up. So I've got a flag set up here, all by the headquarters internationally. So I'm not technically a Canadian. So that can be very exciting for all of us too. It puts us in a different jurisdiction to assist people. I'm also a quantum medical practitioner.
What do you mean, where are you located? You're in the Principality of Canada, I take it, but in a different location. You separated yourself from Canada as such, you mean? Is that what you're talking about?
Totally. It's actually by bloodline. Clan mothers supersede the queen or any sovereign, so I technically hold all the rights of a sovereign and above. And yes. So a clan mother is actually heads a nation.
Right. Okay.
So that's what I'm doing. So I'm probably about an hour south. It's in Kentville, just south of Ottawa right now, just temporarily, till we set back up at Medicine Hat.
Okay, very good. Interesting.
Yes.
A lot of changes happening in the air this year in particular. I think is going to see so many changes all over the planet, and it'll affect all of us. It's great, I think. Some people may not think so.
Well, it's going to be it's going to be an absolutely huge change. A lot of the stuff that is coming forth is actually, they are acknowledging what we're doing. So, I'm glad to see it, bearing fruit, really. It's been a long time coming, so to speak.
Yes. And you have to wait for many, many lifetimes. It gets, kind of tedious. Okay.
Yeah. If there's anything I can do to help anyone too, I also do scale, but radionics, scalar, all sorts of different radionics and remote viewing technology. So in fact, it was ironic. I started doing actually MIHAN today, distance stealing, that kind of thing, around 10. So now that it's 5 in the AM here.
Right.
Yeah, any input to give us a sense of if we're on the right path or not would be very useful.
Yeah, absolutely. You could do what I can. So if anyone wishes, I'll just put it in the thing. This is my Skype, because that's usually how I do that. It's called Karen Mack. All one lowercase.
Okay. Thank you. I'll add that to my list as well. And you wanted to be added to the Keshe Plasma Reactor group, or to the notification for the Knowledge Seekers workshops?
Oh, you could put me on all the above. How's that?
Okay, that sounds good.
I could monitor all of them. How's that?
Okay. All righty. Anybody else who wants to introduce themselves, or a question or other?
Hi guys. Rick?
Yes.
Yes, I really haven't formally introduced myself. My name is Narek Kasparian. I live in Los Angeles, and I'm really happy to be part of the team. And I've been really following the technology for a couple of years now, but recently really just started actually hands-on. So I'm really happy, and just happy to living it this time, just everything's cool.
Right on. Good. So are you creating a power unit, or what is your aspect?
Yes. Yes, I am. I have my stacker ready. I made a lot of ganses, different kinds. I have magnesium, lithium I made just recently. I have aluminum. I have CH3, CuO. I have, what else do I have?
Well, that's the first two you mentioned are very interesting to me because I've been looking into magnesium, and of course lithium is something that we don't normally play with, but it is a very important factor in terms of exchange of energies and that kind of thing.
We call them the Gansmen, Rick.
Yes.
He's part of our little group in LA area.
Okay, I got it. Good. Well, geez, there's so many people that are just growing up like this. They've been sort of watching or been hanging around for a couple of years or more, and then suddenly they're really inspired to just come out. It's almost like coming out of the closet, you could say. And you know, because it is when your name gets exposed to the world and it's associated with this kind of technology. In years past, that could be a lot of hassle, in fact months past, but now there's enough momentum behind it that there's no agency, there's no people, there's no force that can keep this from happening. So it's either the bad guys get on board or they better get out of the way, because that's the way it is. So I think even the bad guys get on board, and they're actually changing and evolving themselves into possibly, you know, functional people and so on. Anyway, I didn't need to get off on that tangent.
Well, and that's been happening actually, because we're starting to be, you know, talking in truth and speaking freely and benevolently for everyone. And according to those original laws of the lands, which people are starting to know about, I just wanted to thank you for being here and for your kindness and for your understanding. So we are at a pivotal and a critical point where we are moving forward. So I think this is one of the most exciting and peaceful times we can, you know, and like we say, we're just getting into that point where a lot of people that have been, you know, they're stepping forward and, you know, they're stepping up to the plate to help now. So it is an amazing time. So, and you know, all the help we could get up here would be like greatly appreciated. So like, I'm just starting up basically from scratch here right now. So.
Yep. And part of what will be happening very soon will be the Keshe Foundation Canada, which is part of what I'm founding, will be happening. And one of my basic core operating principles will be to try to empower the native peoples as much as possible in terms of everything from self-supplied power for them, heat, a better environment in terms of the feeling of it, and all of that, everything associated with this plasma technology. They should be the ones that get it first, as far as I'm concerned, because that's where the greatest discrepancy and injustices have been done. So as part of repairing the past, then that's to be part of my philosophy as Keshe Foundation Canada. And also to try to unite all of the Aboriginal original peoples across the planet, which is also occurring now in several different ways, but that can be facilitated in many, many different ways. It's exciting times, I think, in terms of all that.
Well, one of the things too that I could help too is that being the 13th actual clan mother, everyone technically belongs to a tribe anyway, and that's part of the MT or mitochondrial DNA, which everyone has. So we already belong to one. It's people have to learn what they are, and that's the difference from being colonized. So there's a big difference from being an original or technically nobility, which I am, holding all the rights of a sovereign and above, and someone that's been colonized and Aboriginal, no longer Indigenous and no longer practicing the original customs, usages, and laws. So in order to help those different people. That's why it's imperative to get the embassy technically set up properly, because we already do that. And so you already belong to one. It's people have to find their own. And I'll tell you, 99% of the most people from the red tribes do not know who their clan mothers and stuff are either. And they've lost their teachings as well. So that's part of some of the stuff I have to do, because out of those 13 bloodlines, 5 of us were white. So it has to do with the blood lineage actually passed down like hereditary. So a lot of people they're not aware of that. So they can go to Meredith Quinn and get the teachings. And that is the law of peace, because the International Hague Court, which I deal with, you have to know which nation you're part of. And each one of those nations had a peace treaty. And no one has the authority other than myself to actually authorize one. Because a lot of that de facto stuff we shut down in 2013. Mm-hmm.
That may all work well on a certain level. To my mind, we're going beyond nations and into the essence, which is the same in all nations. And when you get to that level, then it's beyond the differences between nations, between individuals, between cultures, between any of it. You look someone straight in the eye and you know there's another essence there. There is no differences. You are one. And that is where I'm shooting for.
Well, the treaties and stuff like that we're actually governing this planet, or whatever you want to say, covenants, but those original treaties are actually the ET treaties as well. So they cover everything, not only cosmically, universally, but intergalactically as well. And that's where we come in with dealing with the space programs and stuff too. So it is coming back into which I consider to be the co-creation, basically a Trinity thing. So yeah,
Right.
I get what you're saying.
How much we talk about oneness, there's always, because we're on this planet in physicality, there's always duality. There's always the rules and regulations, both of the humanity and of the universe, that we do have to deal with. So yes, and this is definitely
this is universal law for sure. Yeah, that's why I've got the cosmic activation too, but it's the universal law.
Right, the United Nations should have been that way to start with, but it got into a feeding frenzy instead, basically. So that needs to be.
Well, they're not actually the nations at all, they're countries. Right. So united means divided. They took away the people from the original 13 nations and their clan mothers, and they classified them into de facto countries. And that's what the United Nations is. Remember, it's a corporate. It has nothing to do with unity or community.
United corporations rather than United Nations.
That's exactly what it means. It's for the corporals, the people that have come away from practicing their original usages and laws. Like I said, everyone belongs. There's nothing to join. It's to find out hereditary DNA who you are.
Well,
that's the key.
And I just, by coincidence, got a report in from someone today about how he's been studying DNA and RNA, and how RNA continues through the vacuum of space and through the entire universe. And when it gets activated simply by the application of water, then it turns into DNA, and all of a sudden, in the right conditions, here we are. So
that's exactly cosmic. Yeah, it is. It's the mother's cosmos, but it's transferred through the mitochondrial or empty DNA, and everyone can get swabbed for that. So that's easy enough to check, or like Oxford University or Brian Sykes carries that. But to get your mother's, you belong to your mother's clans, tribes, nation. And then there's a woman that will be heading that. Like right now I've got most of it. So, and that has to go from the Anglo nations or whatever. So that's all it is. It's so simple. It really is. So that's the hidden, I'm going to say it's not a cult, but that's what the secret thing is all about. And people have to basically step up and find out who they are. That's that inner journey, really. And you're absolutely right. It's carried down, and it's hereditary. It's kind of like your inheritance thing. And you can look up your coat of arms and DNA on your mother's. But like I said, until you do the swab or the haploid, people are considered lost because they've had the disconnection. They can't prove who they are. So that's the problem right now. And all the alien DNA and, interventions. So but it's going to be interesting times, that's for sure.
Yeah.
I'll talk to Patty. I think.
Go ahead, sorry.
Yeah, no, I'll talk to Patty. Patty's got a lot of stuff on this. Patty's a genius. We're going to be on Revolution Radio this week. We got 2 shows, one tomorrow, I have 2 at Eastern, and then another one Friday. But if you go to the BASIS program, we're the 3 witnesses that witnessed what happened that went on in CERN. Speaking of copper inside and meltdowns. But CERN, Totem, the Large Hadron. So if you go to the BASIS program on 53, we talk about it. And Patty talks a lot about the warp drive and the plasma stuff. So Patty's just starting to release some of the stuff similar to what Keshe's doing. So I will get Patty on that.
Was it the BASIS program or BASICS program?
It's called the BASIS program. Yeah, with Miles Johnston. So if you go to the BASIS, yeah, correct.
Okay.
So if you look at that, Valhalla, Harold talks about the black goose, anything, the AI and all that, what's going on. That's on 46. I'm on 47 and 53 points. I know, I think 4 or something. But we're on, both of us are on like 47 for sure and all of 53. And then there's another one on Healing Circle Network and stuff. We've done quite a few. I've got like a couple years archived as well. I used to run medical centers and quantum stuff and colon hydrotherapy and that kind of thing as well. The Solarian stuff.
I see.
So I think you'll probably find it.
Okay.
Yeah.
Share that info.
You are most welcome. Thanks for your kindness and your understanding. I appreciate it. This is about everyone coming together now. So this is going to be what we're moving forward on. So yeah, I'd like to get actually Keshe, if we could get him talking with Patty. They could probably release and share a lot of that inside information. I know her grandmother was a initial Micmac grandmother, whatever the areas we're in now. But like I said, they were at the Stargate in Iraq and stuff. They hold a lot of stuff, like they were little artifacts and stuff like that. So I think that would be very helpful because they were designing these kind of things and they have had them. They're successful already as part of the space program. So it's just a matter of bringing it forward now to the general population or public, as you say.
Yeah.
So I think we'll get them on. The other one would be to Dan Willis, as Dan Willis was part of the U.S. Navy. I've been dealing with him a little bit on this, and Sergeant Daniel McMullen. There's quite a bit on that, but he was also part of the Serious Disclosure Project with Dr. Stephen Guerin from the U.S. Senate Committee. And he was part with Bedini and stuff like that. David Sereda might be very helpful too. He's doing some vortex and off-grid stuff. And he's in Nelson. I just met with him not too long ago. So, and Hellier as well. Paul Hellier, the former Minister of Defense. So they might be helpful. And
yes, right.
Oh yeah, they all are.
Yes, right. Exactly. Well, it may be time, I think, for us all to upscale a bit and connect with people that are more connected in that sense. And maybe some of them are even willing to become teachers in the online teachings we have, if they have alignment with the Keshe technology and know what that's about so that it can be taught in the way that we understand, or at least Mr. Keshe especially understands plasma and so on, and doesn't get too divisive or divertive, and those kind of D words. And maybe we can cooperate in some way that way with people like that. So and we already have some.
Well, you know, that would be great if we could get Patty together. Patty could have Patty's own cosmic galactic, like, you know, star from a galaxy far, far away. Like, literally, if you want to go to Patty L. Broussard, just look at the albums, and that's the warp drive. Those are the plans we've got for the new things, resetting the triple strand DNA, getting people on Solomonic. It's the missing salt that was used, that was made illegal up here, but we can get it in through some other methods, like through candies and stuff. So, I mean, we've got a lot of stuff to repair the triple strand DNA that we've been dealing with as well. So I think there would be quite a bit. I really think that me and Keshe and Carolina and Patty, we should do it.
Well, if everybody, all the minds can get together to work together, that would be a great thing, I think. So let's work toward that.
Yeah, that's what it is. It's all got to be like free gifting the way it's supposed to be, like community contribution. Absolutely. You know, that's what the piece is. It's all about, you know, sharing, right? No currency. That's about what it is. So, like I said, that was in every tribe, every clan, every nation, whatever. That's just something we all agreed upon here. So, anyway, have a wonderful evening. Thank you so much. I've been such a fan of you guys for so long. I finally got the new computer and Zoom up tonight.
Right on. Great. Thank you very much for dropping by, and feel free.
Yeah, please do.
Come to the workshop as well.
Yeah, I'll do some playing, that's for sure, in the play thing. So yeah, and maybe we could Skype later. So okay, that'd be great. Thanks.
Okay, great. Thank you. And I see. I think Mario's here. Mario, maybe you wanted to say something or show something?
Yeah, but you know, it's been a long session, and after what Mr. Keshe was showing, if I can, maybe I can reevaluate what I have and come back next week.
Sure, that'd be great. Appreciate it. I like your
yeah, thank you for doing all this work.
Your thought train. That's an inside joke. People would have to know your last name to get it, I guess.
Yeah. Well, and I'm moving around a lot too, so
okay.
It's appropriate, you know. But yeah, I have some work, but I think it would take a little long, and if better next week, I'll try to come on, and if it works out, I can share some stuff I've been working on.
Great, great. We'll give it a better introduction next week then. Right on.
It's okay. I'm okay with whatever. It's always interesting. These.
Yes, it is. It's always surprising and interesting what comes up here.
Surprising is actually a good word, isn't it?
If it wasn't surprising every week, I wouldn't be here still, probably.
Do you sleep still at all?
Oh, I try to get quite a bit of sleep now. I actually sleep through the mornings, and I haven't seen a morning for quite a long time.
Ah, it's like a musician's lifestyle. Now you're joining like me.
Yeah, I have a nightlife, but I never go out.
Yeah, right.
So anyways, it's an odd life, but I'm so grateful for everything that's occurring in my life. It's simply amazing the way everything is coming together, and I think the planet's going to wake up here pretty soon. It's entirely a possibility, finally.
I didn't think I was going to live long enough to see this age coming, but here I am.
Yes, that becomes a factor as we get older, and myself, I've been wondering about that and kind of almost gave up for a while, but now I'm hot on the trail, and I'm so happy to be part of this this age and this.
I don't know if you're aware of this, but Sir Isaac Newton wrote a book around 1700 called about the Book of Daniel. I don't know if you're aware of this. He calculated the days of years, the number of years when the coming kingdom of God would come, according to the Book of Daniel. And he determined that depending, it should be the year 2030 or the year 2034 as the time.
That seems about right.
Well, yeah, I never put very much stock into those things, but it seems to sound about right now.
Of course, those on the leading edge are always a few years or a decade or two ahead. So,
yeah. Well, 7 billion people got to get it, so.
Yeah, that's right, and that takes time. And there's so many different cultures that are closed off, and so on, and others that are rapidly opening up. And it's such a dynamic picture right now. It's crazy.
Yeah, I mean, the Chinese are really doing a lot of things. I sometimes got to work with some of those guys in Hangzhou. I mean, they translate absolutely everything. Lisa and Max and these guys into Chinese, which...
Yeah, we have to get them harnessed a little better. They're amazing at rapidly coming up with these transcripts and so on. It's have to get them more accurate and organize it a bit. But yeah, that's right. They just sort of glom onto it. And
Lisa Audio transcribes them, you know, he just dubs in. But the transcripts, I don't know, usually you might want to check your email. I don't know if you got some of the, I sent you some subtitles, and I should have a couple more for you too. I don't know if you, normally you got back to me and told me you got them and you didn't. Maybe
no, I don't remember that one, and I've gotten some lost emails because I've been so overwhelmed.
I figured that. So the only reason I'm mentioning it is that you didn't check in case you didn't. There were at least 2 or 3 more that since whatever, and I've got a couple in the pipeline.
Well, that's a good point, Mario. And I put out to people, if they have any transcripts of any of the Keshe teachings, please get them into either me, or what's even better is there's a new website that's keeping track of the various things called transformacom.com. Just let me get the
yeah, that's an excellent one.
let me get the
well, I've been proofreading the Chinese ones. Some of them are okay. A lot of them have to be rewritten, whatever. But there's at least, I mean, we did the last 3 or 4 workshops and a whole bunch of the health workshops and kids workshops. So, and I've been putting as many as I can into subtitles.
Okay, well, wow, that would be very useful. And what you can do is we're using this as a kind of a central location right now. He's got a database rigged up with all the Keshe videos, and what has been done so far as transcripts or translations and so on. And there's some
right,
so that people can tell what's already been done and then can contribute, because we don't want to start duplicating is the thing. We're still adding to this database, and I'm hoping that I'm going to have a manager soon for managing the transcripts and translations and really get it together in a professional way to make sure they're all done and keep getting done on a as soon as possible basis. So there's going to be a lot of changes in the next little while with all that, and hopefully we'll be more efficient. So yeah, you can.
Should I send what I have to them, or I contacted them, or just leave what you have with you, right?
Well, you can send them to me and I'll send them to him, or if you want to send them direct, you could do that as well. Just I'd also like to have the files so that we have them.
Okay, I'll send you just check for the email. There should be a few. If you didn't get them, maybe you got them already. And because I haven't sent you in a while because I've been kind of busy. But then I've got at least a couple more. But there might be 2 or 3 there that you didn't get yet, because I figured you were overwhelmed.
Yes, I was. I had like 4,000 email messages, and
yeah.
Most
well, normally
deleting the ones I didn't have to look at and just getting a pile of the ones I have to look at, and I haven't addressed most of them yet. So you may have been in there somewhere.
Well, so check, then there might be a couple of transcripts that are ready to go there. So
great, excellent, thank you. That's what we need right now. So we're looking for the transcripts to get them up on that site. And like I said before, we're also looking for people's stories, or what do you call it, testimonials on health pen, healing pads, or the MagGrab units as well. Just any testimonials are all going to be put up on a central location in the Keshe Foundation website. Okay. I think, is that it for now, or shall we shut her down, or what do you think, people? Is there more questions or comments?
I'm great. Are you great?
I'm good. I'm
Are you?
pretty toasted after 4.5 hours of this, but it's good. I'm really happy. Everybody showed up, and we got in some great stuff here tonight. So
I was just trying to look. Were you on at Sook? Was I correct when I looked at your Facebook?
that's where I am. Yes.
Oh, I was thinking Langford in Victoria. I used to have a place. I did my biofeedback, but right by Lifestyles on Burnside and Douglas is we used to have a health center there. But I was in Nanaimo for quite some time, and Christina Van Art, one of our former girls, she does.
What was the name of the spot beside?
It was a quantum healing. It was a quantum healing center.
That's what it was
right in front of the. Yeah, it was like a rental. There used to be a rental place, but right down from Lifestyles, and right across from that Travel Lodge. And then I was up in Nanaimo for some time, right by Departure Bay, by the country club area. So, but Christina's still in there, and she does a lot of the well, she quit the biofeedback, but she's doing the amethyst crystal beds. So, and I just, because of the radiation levels. Yeah, I do amethyst crystal, far infrared. I do scalar radionics, skew biofeedback, all sorts of things as well. Colon hydrotherapy, matrix energetics. I don't know. I've got about 30, 40 modalities, and ICU nurses, everything.
I see.
Oils, raindrop. Think of it. A face reading. Think of it. I probably do it.
Wow.
Setting up law, setting up embassies off the grid now. You know, international law. So.
Yeah,
That's the way to go.
No doubt. Holy cow. Okay, well, enough about the local vicinity here. People international around the world wouldn't have a clue what we're talking about, but I know exactly where you mean. Thanks. Okay, so I think we'll wrap it up for today. And it's been great fun. So thank you everybody on live stream. I didn't answer all the questions on live stream, but we certainly interchanged when people got onto the Zoom and so on. So that was interesting. And see you back here same time, same place next week, hopefully, as the universe rotates. And I guess that's it for now. So once again, thank you everybody for attending.
Thanks, Rick. We appreciate it.
Just the live stream.
Thank you, Rick. Bye.
Good night, everybody.
Good night. Good night.
Night,
Take care. Bye-bye. Oh,